Yes.
So Mats, we're starting now. Actually, the time is past 1 o'clock in the afternoon, and we are starting to show the schedule for today.
Yes. So this is the schedule for our agenda for today. In a second. Yes. We'll start now at 1 o'clock, and we will go through this event throughout this afternoon. We will stop for some shorter breaks when it suits the agenda. We have not set the time for that yet, but there will be at least 2 breaks during the afternoon. And one of them is going to be a little bit longer, so you have the time to get some coffee or visit the restroom or whatever you need. But what do you say, Terese? Short presentation. My name is Mats Larsson, board member of SEIIA since we started. And I'm really happy to join you throughout this afternoon. And this year I have by my side Terese. Would you please present yourself?
Yeah, actually, I'm Terese Lilliehorn, and I work as a communication officer for SEIIA, and I'm quite new in this area. I've been working around the sector, a lot in the building sector, actually, and I think it's really happy to be working with these questions about interoperability. That's a really hard word to say, but easy to understand when you try to think about all the great parts of why we should work this way. And I've been working with digitalization for a quite long time. So I think it's really great to be in this sector and meet this audience.
Yes, it's a great honor for me to have you, and that we together will help all participants throughout this afternoon. To start with, our first speaker in line is our own Erik. So I think welcome up on stage, Erik.
Thank you.
I'll leave the stage to you now, and we see you soon.
Yeah, thank you. This will work.
Do you want me to share instead? No. Seems to work.
Oh, it worked. Thank you very much for this opportunity. And as Mats said, my name is Erik Molin, and I'm the operation organization with Terese in SEIIA. And I would like to have a little bit forward-looking and also looking to into the history, and also what we are working with as a mission, you could say. This picture is from the history. Our history is not so long. The association was founded in 2019, and it was a result of a project that we called Lifecycle Data Management. And in that project, we tried to use DXP in a very interesting use case.
Erik, did anything happen to your sound right now? Because I don't hear you.
I also can't hear him.
No.
You don't hear me?
Now we hear you again. Something happened to your sound.
Okay.
If you try
Was
to...
Was I away a long time or?
Just a minute or two. So if you start from the beginning of this picture again, it would be great, I think.
Okay. Thanks for letting me know. Okay, I got it from the beginning. The association SEIIA was founded in 2019, and we started with a project actually 2017, which called Lifecycle Data Management. And in that project, we tried to study DXP, because for us, DXP was totally new. And we set up a project and a use case where we have the different types of stakeholders that try to use DXP in several parts of the life cycle of a plant. It was that was the idea with the use case. And then we continue after we founded the organization in 2019. We have continued with several projects, and right now in September in this year we ended up with a project that called Digitala stambanan, our industry case 5. And right now we are in the middle of a European project called Arrowhead FPVM, where we participate with it's 42 partners and from 12 countries in Europe. So it's very interesting, and I think several of the speakers will come back to that also. And right now we are starting up a new project that we'll come back to later in this present today, Digitala stambanan phase 3. And so that we will come back to later. But as you could see, project have been a very main part of our history. We don't have so long history, but the history we had is mainly based on different projects, and that's also where we're looking ahead, that we are still working with project, because these things, the effects of working with project with close to the industry is the best way of adopting these standards, and these are the ideas that SEIIA and our partners are working with all over in a global context. Yeah, if I continue, one of the goals that we are working with is that we try to make the industry more digital. That's not maybe so difficult to understand, but we also think that we need to make a change in our way of working. So that's why I put in this old paradigm and a new paradigm picture, because I think we need to move to a new way of working, and that's also connected to our project that we will present later today also. But and one of them are that if you look at the industry today, if I'm talking about the Swedish industry, we are very focused on document approach. I would say in the future we must go step by step to a more data approach. And also when you look at document and the data, it's, if you look at the historical way of your working, you made documents, and documents are often snapshots of data. So we need to make the data the first, and the visualization of information in a document way more for the, that's the way we want to achieve for the future, that we have that approach, that we have the data and we try to visualize the data for the humans who need it. So that's one very central thing, I would say, for our work now and in the future. And I also want to look what it's fundamental for SEIIA, because something is very important for us to come back to all the time, and that one is, the one of them is not to invent any wheels, because we have found out during this project that we have run that we are trying to invent the wheel too much, I would say. And when we have international standards that we could base our work on, why don't we do it instead of try to invent something new? And when you talk about interoperability, it's a global question. You can't solve the interoperability information, digital information exchange on a national or on a company level, because all the vendors, all the work that we are working in has a global context. So we need to have that eyes that what we are working with is global, not something local and national that we're building up. And that's the last thing, that we work with non-proprietary systems and strategies, that we don't allow somebody to say, you need to follow us, instead of you need to follow us. Do you understand what I mean? So that doesn't have vendors who say that you need to change to our way of working. It should be the opposite, that the vendors should be open and could connect to each other in an open and standardized way. Some other thing is, for us, is very important also, that's the future. And the futures are the children's. And if we look at if you have a 10-year-old girl or boy today, what they daily, what they do? They use computers and mobile phones and all that type of equipment. When they come into the industry in some years, 10 years or 15 years or whatever, how could we prepare their future in a way that they are born? I think that is very important for us. And myself, I'm a 60s, and I sometimes think, is I'm the right person to prepare the new generations for the industry work? So that's, I think, something we need to ask ourselves, and how could we prepare the new generations? That not based on what I think is the best, what is the best for them. And in that change also, you have the digital change, you have the digital adoption, you have the digital transformation and all that. You also have this change adoption curve. I think it's very interesting to have that in mind. Some of us are early adopters. We need to come into the early majority, and how could we get the late majority with us? That's something we really work hard with, I would say. So this is to have this in mind, that where are we in this curve? Because I think some companies have come quite far, and some have maybe just come to the innovators phase. So it's important to have this in mind. So I will end up in the next the last picture for me, our mission. You could say, what are our mission? But I think the mission for us is to help the industry to be more digital in the future, to be more working with visualization, to try to get the industry more convenient with the new generation that come into because if otherwise we don't have a big problem with the people who's going to work with us in the future if we don't prepare our way of working for the new generations. So I think that was the last slide from me, and it's time to continue.
Thank you, Erik. Please stand by here in the camera if we have any questions from the audience, maybe. Can you, Terese, see if you have any questions?
No questions yet that I can see, but I have a question for Erik. If you are looking back to the time before SEIIA was started and what had happened during these 5 years that the organization have been alive, could you see like changes before SEIIA started and how the sector is today?
One big thing I think is the two presenters that we have later today, CFOS and DEXP. I would say before CFOS and DEXP was quite unknown in Sweden, and I think that's something that we have contributed to the Swedish industry and to Sweden, that now a lot of people, not everybody, but a lot of people know about these two very good initiatives that we will hear more about later. But if I just put something.
But in context of that, if you look into the ball of glass, what can you see 5 years from now? Where will Swedish industry be, and where will SEIIA be in 5 years, you say?
What I hope or what I think?
Yeah, what you hope, of course.
I think my hope is that we continue to adopt standards and continue to work with this. For example, DEXP, CFOS. I hope now we have soon Christoph, Attila about Digital Change Consortium. We continue to work with an international community and adopt the good thing, and also our best practice that we start working with in Sweden, that we also could get that back to the community international. So because we know that, for example, in Sweden and Finland we have a lot of pulp and paper industry, and this concept maybe not made today to fit pulp and paper exactly, but it's better to adopt and develop the concept so they fit the pulp and paper industry instead of inventing anything new.
That means that we can we can contribute with the help of making improvement in those initiatives by develop and work and adopt these things at home.
Yeah.
Good.
So I think that's.
Thank you.
Thank you.
Thank you very much. So, time for the next speaker, and that's Christoph. Are you with us?
Yes. Hello to everybody.
Very welcome to SEIIA Interoperability Days for 2024. And please, can you present yourself?
Then I will share my screen with you. Now you should be able to see my presentation.
Quite soon, I think. Now we see it. And would you start to just present yourself and tell us some words about who you are?
Yes.
Marvelous. Thank you.
So first of all, thank you for having me. My name is Christoph Attila Kuhn. I'm from BASF, the chemical company. And within BASF, I'm the global product manager for the digital data chain. And you can see here the logo of the digital data chain on the top right corner of the slide. So today I'm here in my role as manager of the digital data chain consortium. And I would like to present you a very important topic in Europe, the digital product passport that is currently under development and is part of a new EU regulation called Eco-Design for Sustainable Products Regulation. I would like to show you the connection to the digital data chain technologies and also give an outlook on possible collaboration between SEIIA and DDC. Good. Then I would say, let's get started. First, the question, what is the difference between a digital product passport and a digital twin? That are maybe the two main buzzwords in this area. And it's very simple. The digital product passport actually is the collection of the product information relevant for circularity and relevant for the authorities. It is part of the Eco-Design for Sustainable Products Regulation, and it is mainly driven by the different authorities that we have in Europe. So in regards of tax, product compliance, environment, also small and medium-sized companies and business in general. And it is part of the digitalization strategy of the European Commission. And from industry perspective, we see the full-scale digital twin. So that means our approach here, and we call it DPP 4.0, is really to have a look at everything that is relevant information from a product, so that you can say the digital twin is actually the collection of all information of a product, including the ones of the DPP. And just to give you an example what the difference is, if you have an electronic product, for example, then the digital product passport would require information about the materials, substances of concern, how you repair it, etc. But for example, the software drivers were not part of the digital product passport, but they are part of the full-scale digital twin. So that means all the information that is not related to circularity and authorities, they are part of the full-scale digital twin and complete the picture on a product. Good. So what does the European Commission require from us, and where do the requirements come from? So this is actually a slide that I took from an ESPR webinar in May of this year. And here you can see the main information requirements that we have. So typically the green ones we are very familiar with in the industry in regards of durability, repairability, reusability, reliability. So that are the typical informations you provide with your normal product information. The blue ones, they are new aspects, like for example, the recycled content or the water use and efficiency during the production. So these are new data points, new data requirements we received with the ESPR. And there are the orange ones that go into the direction of building a new business, I would say, based on prolonging the lifetime of the product by refurbishing it, remanufacturing it, or also to recycle specific parts of the product. So, and based on this, the ESPR said that there needs to be a tool that we can use for this, a system, how to provide this information. And this is basically the DPP system that is currently under standardization at the CEN-CENELEC, so the European standardization body, in the Joint Technical Committee 24. Good. What are the main design features of the DPP? So as already said, we distinguish between the DPP system, so basically the technology, how you provide the information, and the DPP content or the DPP data that is specific for each type of product, because the information maybe for a detergent are totally different from an electronic product, but both should use the same DPP system. And in the ESPR, there are 8 main architecture aspects defined. You see it here on the top left, on the lower left corner. So unique identifiers and data carriers on the product, and access rights management, because there are different stakeholders who want to access the information. Very important, the interoperability, and there we have the loop that closes to SEIIA, the data processing, data storage, and data authentication, and also the interfaces to be able to perform all of these tasks. Good. What are the main design features? So what is very good from our perspective is we want to have a decentralized approach. So not one huge database at the European Commission that hosts all the product information. It will be decentralized, and it will mainly rely on the manufacturer providing the information and a backup system with a copy of the digital product passport. That is actually the last bullet point that you see here. The second one is each product shall be uniquely linked to a product and a DPP. So that means whenever you have a product, at least there must be a DPP on product level, but it also could be on batch level or instance level or item level, depending on the product type and the data. The data access will take place to a unique identifier with a lookup mechanism, and I will show you later one very convenient. And the information will be shared on a need-to-know basis. So no manufacturer will have to provide sensitive IP just for free. It will depend on what your requirements in information are. Yeah. So for example, tax authorities might have an interest in information that is only for them relevant and will not be shared with anybody else. The identification will be, as already said, on model, batch, and item level, and there will be different types of identifiers required. Good. So what will the companies have to do if they want to provide a DPP? So the one thing is they have to ensure that they have a product passport and that it will be provided. It must be complete in regards of the DPP data that is required. And this data will be defined in so-called delegated acts. So for each product category, there will be a separate delegated act that gives you then the data set that you have to provide. The information must be authentic, reliable, and verifiable. So just to build the trust in the information that you have there. It's important for the consumer perspective, but at the same time also in the B2B area. So when we, for example, as operator of chemical sites purchase something and we receive a DPP, this information must be trustworthy for us, otherwise we cannot use it. Then, as already said, you will have to provide a backup copy in case that your company leaves the market for whatever reason. You just give up your business or you go bankrupt, whatever. Then the idea is always provide information to the DPP, even if the manufacturer left the market. And you should provide the product identifier upfront to any kind of online marketplaces that they are able to access the DPP information. Good. So which product groups fall under the ESPR? So in the end, any product except food and pharmaceuticals will have to have a DPP, but this will be not happening within 1 year. So they have a working plan that says we will do it step by step. And you can see here the different categories that they have. So the first ones will be batteries, so big traction batteries for cars. They will have to provide a DPP in 2026. And afterwards, step by step, the different product categories that you see here will have to provide one. I just marked the ones in blue that are mainly business to business, but there are also a lot of other ones that are more consumer focused, like for example, the yellow ones, but they are all relying on chemicals as raw material or material for their products. And that is the reason why BASF as chemical company is so much involved in the topic, because we are provider of the raw materials to all these different products. Good. And what is very important, so the interoperability of the DPPs will be one of the main factors regarding the costs and the impact on Europe's competitiveness. So that means if we don't manage to have really interoperable DPPs, if possible, based on open standards without any vendor lock-in, then this could have a significant, in the worst case, negative effect on Europe's competitiveness. And therefore, it is very important for the industry that we actively participate in the standardization of the DPP system so that we can ensure that it is really all interoperable and we don't have any vendor lock-ins. Good. The stakeholders that are involved in the creation of the DPP are the EU regulators. So you have the Parliament, the Council, and the Commission. It is mainly driven by the Commission, and they define the DPP architecture and content in a way that they say these are the requirements. How you fulfill them, that will be defined in the standardization. So in the regulations part, we did successful advocacy and ensured that, for example, free technologies like the asset administration shell, etc., are regarded as possible solutions in the DPP and ESPR. In regards of the project that develop DPP concepts and pilots, we have been also successful as industry. There we are part of the Surpass 2 project and can show there in the DPP pilot for electronic products what our approach in the industry is. And there will be the delegated acts, as already mentioned, so they will give the product-specific requirements. And now comes the part where we need more involvement. So in the sense-analog standardization of the technical framework, that is where we need to participate as industry much more than we did it till today, because that is where it will be decided what technologies will be used for the DPP. Good. So what is important for the industry and why should we participate there? So the standards for the DPP are developed currently in the Sense&Elect Joint Technical Committee 24, and they will determine the technical basis for the EU DPP system. So that means all future DPPs for any kind of products will then have to use the technologies defined there in the DPP standards. Other ones will not per se be accepted. Yeah, so there might be the possibility in a delegated act to define a specific technology if necessary, but typically this is not expected. If we really would like to have a cost-free or low-cost DPP system, so that's the place where we have to act. Yeah? So if we want to keep the data sovereignty, we must now be actively participate and contribute in the JTC 24 standardization. Otherwise, the DPP system will be mainly designed by the commercial service providers that are already participating in the Sense&Elect JTC 24 standardization. So if we would like to see interoperability, no vendor lock-in, and cost-free or no-cost solutions, then we have to be active there. Good. So what I brought you today is a little example what industry participation can move. So there are different standards that you can use for identification, the ISO IEC 15459 based identifier and the EN IEC 61406 based identifier. The left ones are typically used today in retail. The ones on the right side are mainly used in industry and B2B. And what I just made is I took a typical license model of the 15459 basis and just compared it with the EN IEC 61406. And regarding the 15459 based identifiers, you buy a license with your company identifier and some additional services typically that you can have, maybe a range of 1,000 products that you can combine with your company identifier. So this typically is based on the company size, the fee. So that means the bigger the company, the more you have to pay. And it is depending also in which country you are, because they all have different rates there. Where compared to that, when you use an IEC 61406 identifier, it is based on the web domain of the manufacturer. And actually, there is no difference between being a small company or being a big corporation. You just pay the hosting costs at your domain provider, and that's just a flat. It's the same, independent from the company size. And this is very friendly, especially for small and medium-sized companies. When you look at the product-related license fees, then many of the 15459 based identifiers, they just give you a specific amount of products. And if you have more products for which you want to create a product identifier based on your company identifier, then you will have to buy an additional range of products. So that means the more products you have, the higher the costs will be. So if you compare this with an IEC 61406 identifier, as it is based on the web domain, there are actually no costs that are related to the amount of products that you base on your web domain, as you are actually the owner of your web domain, and it is up to you how many products you will base on this. So here you already can see big differences in the costs. That does not say anything about whether the one is better or not as the other one, but there are significant differences in regards of the cost. And it is the same when you look at the topic of implementation in your existing IT systems. So on the left side, you see an 15459 based identifier. And as you have to create the matching between your existing ID system and 15459, if you not already use 15459 based identifiers, that would mean that somewhere you will have to have a database or at least a table that gives you the matching between your existing product identification system and the 15459 based product identification. And whenever you have an IT system that is already based on your current system, you will need to make a translation. So that means you have to translate from a 15459 ID into your existing one so that you're able to process this. And that is the big difference to the right side, where you have an IEC 61406 based identifier, where your existing ID is part of the identification link. So that means actually you just combine your existing system with your web domain. And by combining the existing system, it is very easy just to extract your regular product identifier and just use it in your IT systems as you did before. So that means actually if you use IEC 61406, you don't have any major changes in your IT systems, where with an 15459 based system, it will be necessary to do these changes because you have to match the two with each other. Good. And this shows why it is so important for industry to participate in the SEIIA standardization so that we can ensure that low-cost solutions like, for example, the EN/IEC 6106 identifiers become part of the SEIIA standards. Good. To make it a little bit more tangible, how does this ID link work? It's more or less the same like what you have with your private ID. So there you have two main properties, the country of citizenship and your ID card number. And these two data will be used to identify you all around the world. And what we actually did, we just transferred this to physical items. And instead of an ID card number, we use this QR code, and you see the frame with the black triangle. This indicates that it is not just a random QR code. This indicates that it is a QR code containing an ID link. And as already said, it is built based on a web domain combined with a free text. And the free text could be your existing product identification system. I will show it in 2 slides. So, and this is standardized in the IEC 61406. So you see, everything that we need is very simple web technology, nothing sophisticated. You keep full control and sovereignty about your data, and you don't have high costs because you can use your existing web domain. And here you see now the connection. So the country of citizenship is what your web domain is, and your ID card number refers to what the free text is in the ID link. So this was item-based identification, but we also need identification on product or batch level. Therefore, we inserted this little green part, the city, the system identifier. So you see the question mark .s equal signs. The S says that it is a single item. And if you have there a P, then it says it's a product. And you have then the same identifier on all the 4 products on the top, because it is only identified on product level and not on item level. And you also can see here a difference. You have the frame, and the lower right corner, the triangle is missing here. That indicates clearly you have an ID link, but this one is not on item level, it is on product level. Good. And what I made here is just a comparison of a lot of different ID systems that are operated. So you have, for example, the steel industry, then use the steel quality and the batch number and the date. You might have a small SME and turning milling company that just uses the purchase order. You might have a process automation company that uses their product name and maybe a serial number. You can have an automotive industry using a DUNS number, product code, and serial number, or you have a retail business and you use a GTIN. So these all look very different, but they all can be expressed as identification link. So you see, you just combine the web domain of the company with the steel quality and the batch number, and this string is unique for the batch. And you can have this with all the existing ID systems. And the important part is that you don't have to change your internal IT system. You just use your existing product identification and combine it with your web domain. And that is everything that you have to do. No matching table, no service that you need to extract information or to look it up. You can just use what you have. And therefore, this is really the standard to make any kind of existing product identifiers interoperable with each other. And that is actually what we need, because it is really low cost or no cost, because you can use your legacy ID system and just combine it with the web domain of your company. Good. So just to give you an impression, I would ask you all to just take your private smartphone and please scan on the top right corner the QR code. And this should lead you then to this page here of Siemens that gives you the full digital twin of this product. And there is even a machine readable part integrated. It's the 3rd position here that is marked in yellow. That's the asset administration shell package that provides in a machine readable format all the properties, all the information to this product. So if it works, just give me a thumb up that I see that I can continue with the next slide. Okay, did it work? Okay, I see Heiner raised his hand. Then I assume it worked properly. Good. So this was the overview of the product identification and what the approach from industry is. Also, why it is so important to participate in the standardization. I would like to give you also a short overview on the whole digital data chain, because the identifier is just one of the 3 technologies that we use. So just imagine you have a manufacturer, an owner operator, and we buy, for example, an electric drive. So the first technology is this global unique identification based on the EN/IEC 61406 ID link. That is what you yourself just tested, and you performed the access mechanism 1. You scanned the QR code and went to the web page of the manufacturer. So the second technology is the intelligent documentation. So that means we not only want to receive a PDF file and no further information, we also would like to have the metadata. So who created the document, what document type it is, what language it is, which revision it is. And that will be provided in the VDI 2770 format that is currently becoming an IEC standard. So the new work item proposal just has been released. So, and what we did then is we combined the 2 technologies by adding the content of the QR code, the global unique identifier, as one property of the document. And this, for the first time, really connects the physical equipment with the digital information to it. Because now you can search documents and just search for the documents that have the same identifier like your physical product, and you can find all the information to this specific product. And to make the access convenient, we are using the asset administration shell as format to provide the information, and it will be processed in an information exchange platform that is independent from the manufacturer and also independent from the owner operator. The manufacturer just places the information there, and the owner operator can access it freely by just scanning the QR code and being a member of this specific platform. And at the same time, this platform serves the purpose of the digital product passport backup copy. So for the manufacturer, it is a very convenient way to provide information and at the same time fulfill the requirements of the DPP. Good. So you can imagine this is something you cannot do on your own. So there you need a lot of partners, and therefore we founded the Digital Data Chain Consortium to spread the technologies, create the international standards that are necessary, and right from the beginning have the critical mass to create enough momentum for the implementation of the technologies. And what you can see here is the list of member companies. And you see there are a lot of owner operator like BASF, Bayer, Evonik, Lanxess, Merck, Roche, Sanofi. But at the same time, also the suppliers. Like, for example, ABB, KSB, Andres & Hauser, up to Yokogawa from Japan. We all included them into the consortium. And last not least, also industrial service providers like, for example, TÜV Süd or Tectrion, who is a workshop operator. So we brought together all the different stakeholders that need product information to perform their tasks, the providers of information, the users of information, and together we define the requirements and develop the standards together. Good. And our proposal now would be, and I think Erik already mentioned it, so we see a big benefit on both sides in collaborating with SEIIA and Digital Data Chain. So we are already collaborating in the JTC 24 standardization of the DPP. There I work together with Erik in the working group 2 for unique identifiers, for example. But we see there are many more topics and fields where it would be really great to cooperate with SEIIA. And therefore, that is our proposal to go here into a memorandum of understanding, just list define the topics where a collaboration could make sense, and then we would be very, very happy to also have a collaboration with SEIIA in this topic. Good, that's it from my side. I just stop presenting and I'm happy to answer your questions. Thank you.
Thank you, Christoph, for a very interesting things that you show us. My point of view is that we probably going to see some of this also next year, because it's so big things happening and it's ongoing. We have some questions from the audience. I have two questions from Micke Rudin. Will you please, Micke, spell the questions yourself?
Yeah, I can do that. Well, first thing I would like to know, I mean, how do the DPP actually handle composite products? Products out of products and products that are made out of components. Is it supposed to be references between these products and well, really, how is that handled?
Yeah, so that's a very good question. So currently in the Eco-Design for Sustainable Products regulation, the DPP is required in the first step for the final product. So that means for a product that does not become part of another product. But you see with the traction batteries of cars, which is clearly a component, there is already another approach. And what we expect is that for any kind of product, because also chemicals and you have steel and aluminium there, and DPP must be provided, the expectation is that you will have the DPPs for any kind of product. But what is not written in the ESPR is that you have to link together the DPPs from your supply chain. So currently the approach is that each manufacturer collects the information from his suppliers. That can happen with a DPP, but must not. And he will create then a DPP based on the received information. It is not required to forward the DPP of your supplier. But I expect that, for example, package unit suppliers, they will typically just combine the DPPs or the digital twins from their sub-suppliers. So just imagine you have a process cooling unit. You have the chiller, the drive, the gearbox, maybe a control cabinet that will be delivered from different suppliers. And as integrator, you will just create your own DPP that then references the DPPs or digital twins of your suppliers. So that is what we currently see, but there is no hard requirement from the ESPR. I hope that answers the question that you had.
Yeah, thank you. I think we have had a lot of work around how do you model a plant and things like that. And I can understand this has not been sort of considered so much in building the DPPs, if I understand you right.
Yeah, correct. So there's at least no specific requirement. And I think this is something that we as industry have to figure out and find there a good solution.
Yeah. The other question I had was that why aren't we using GUIDs as identifiers? Because GUIDs has the capability of being generated by anyone at any time, and they are still unique. And I think that this should be the sort of the main problem with keeping this identifiers, is to figure out a way to get unique identifiers. And then if you want to have a GUID combined with some kind of URL or something like that, that's okay. But as soon as you find a GUID and it's on the product passport, you could actually know that anything, the information that has, well, connection to this would actually be valid. So why isn't that used? Do you know that?
Yeah, it's a very simple answer, because nobody brought it up in the Sensana like JTC 24. So that is why it is so important to participate in the standardization. Only the technologies will be taken into consideration where somebody is there and says, look, we have here a good technology that has a lot of advantages. We should take this into consideration. So that is actually the main reason why we should participate as industry as much as possible to ensure that from our perspective, relevant and good technologies will become part of the standards.
Okay, thank you very much.
Thank you very much. We also have a question from Ilse.
Yes, hello, Christoph. Thank you for your very clear presentation. I was just asking about how you see the general position of European industry. Do you feel that they're all on track, or is it only the ones that have actually found DDC that know what they're doing and what is coming?
Yeah, so I would say we have two main streams there. So the one is the retail industry. They come with an own approach, and I would say we have the more B2B focused industries that have an approach. So that are the current main streams that I see there. But what you cannot say is that there is one position from the industry, whether they are producing for retail or B2B. So this is something where we really have to align with them. And that is also part of our work in the Joint Technical Committee 24. I learned a lot about retail business, how they are approaching a lot of topics. And we shared with them our experiences from operating huge factories or sites. And slowly we come together. But this is very important, why we also have to participate there, to learn from the other ones, but also to show them what we already have and use. No?
Okay, yes, thank you. Good.
Yes, last question was from Johan. We have 1 minute to go.
Okay, thank you very much. Where is the automotive industry nowadays and the software industry like Microsoft?
So they're participating, but not as much as I personally expected. That might be because there have been started other initiatives earlier, specifically for the automotive industry, like, for example, Catena X. From the software side, I was surprised that there are only a few software companies that are really directly participating in the standardization. So amongst the big players where I would have expected it, also the big online marketplaces, I would just say it's maybe 30% who are really participating directly. And I hope that this changes within the next weeks and months. So we are doing a lot of discussions with software suppliers and also the big marketplaces that they should join, because in the end, they will be one of the main users of the DPP. No?
Thank you very much.
Thank you very much, Christoph. I can see
You're
that
welcome.
it's a very important issue to discuss, and I really hope that we can come back to you maybe next year and see where we are then. So once again, very big thank you for being with us here today. And
thank you for having me.
On stage, we will have Malin. Are you with us? Malin?
I am here. Just trying to find the presentation at the same time. Thank you. Very interesting presentation there. Thank you so much. And now something completely different, right?
Yes. So the stage is yours, and welcome.
And we're on in English, right?
Yes.
Very good. I hope that the audience can cope with a bit of Swedish on the slides. I was a bit mixing pictures, but I guess you're all used to mixing languages in this area. So let's see if I can pull up my presentation and in the right mode as well. How does that look to you?
We don't see it yet, though.
You don't see it yet, though. Let's see if we can make that happen then. It's good that you keep track of this, Terese.
Yeah, I have it. I have a backup if you want me to share it as well.
To find my way back into the Teams meeting, and we do sharing. How about this then?
Yeah, perfect. Thank you.
Very good. A very lilac starting picture, right?
Great.
And timing-wise, Terese, how much time do we have now?
Yeah, you have 15 minutes.
Okay, very good.
Oh.
Very good. Just checking. We should run quicker than usual. What is PiiA? That is the question of today. I am the program manager in this program. PiiA works with process industrial IT and automation. To begin from the very beginning now, I guess that some of you already know the program, but maybe not everyone. So I'll take it from the baseline. There are 17 strategic innovation programs in Sweden. They are financed by Vinnova, Swedish Innovation Agency, together with Energimyndigheten and Formas. So these 17 programs address different segments or sectors typically in the market where we have a development need that comes from the stakeholders in these respective industries. And that was the beginning. And PiiA started out in 2013, a very long time ago, where the process industry came together to talk about the need of digitalization, which we at that time called innovation, automation and IT. Nowadays, more digitalization. And PiiA these days, we work, of course, with the other programs as well, and with new programs who have come to this conjunction since 2013. But we work with all the different branches within process industry. So forestry, pulp and paper, mining, minerals, food production, pharma, life science, metals, energy, and chemistry and petroleum. So there are quite a few different segments to learn about, and I think that's one of the very interesting objectives for this program, to combine people with that expertise in the domains, but also those who have the expertise within digitalization and, as mentioned now, the software community and all this, how we come together and discussing things as data-driven decision making and things like that right now. So starting out in 2013, we're going to go all the way until 2026. To New Year's Eve. So we have 2 more years to go in the program. We've been launching open calls to foster projects within this program, about 20 different calls. So all in all, that has made up soon 300 projects within those different domains, with about 500 different partners. So quite a few different organizations, both companies and academia, who have been participating in the PiiA program. And in total, we have about 1 miljard Swedish crowns invested in this, and continuing to investing, of course, in this important area. Just say something about how we run this program. So I'm the manager of the program office. We are pretty much the ones who do the operations and connect with the projects, but those who make the decisions about the program is the funding agencies, of course, together with this board, where we see quite a few other companies who are active in these sectors. We have ABB, Stegra, previously H2 Green Steel, SSAB, Skogsindustrierna, Siemens, Billerud, and Boliden are on the board right now. The program efforts are directed into 3 different channels, so to say. Projects, of course, is a giant sector, of course, the very biggest one, where we try to keep connected with the projects and see how they are progressing and what kind of results we can bring back to the whole process industry. And then we have PiiA Insight, which is pretty much a report series where we produce analyses and insights from this moving target. How do we implement digitalization? How do we work with this to improve efficiency in process industry? And then the networking side is where we try to connect with other people and programs and projects who are interested in the same things as we are. That's why we're here today, for example. Now we want to work even closer with SEIIA and SEIIA partners, of course, and just be as efficient as we can with resources, people, and money going forward in this area. A little picture about how we envision our role in this system. And that's in Swedish. That's not the right language for today, of course. So in this whole value system, of course, we look at technique, but also infrastructure, where we have like energy, data, transports, regulatory, as we just discussed now for the DPP and how we handle that. And going down to the baseline where we have people, operators, users, the network, and the exchange system where we look at materials, waste, and again, energy, and how the digitalization is a carrier of different values in this industry, and how we're all, of course, connected in the big value system through the digital value chains that we have here. A bit more pictures. This is a few charts describing how our efforts have been targeted in different industry segments. So looking at the biggest one in the middle, we can see that we have quite a bit of projects and also money directed to cross-domain projects. And I think that's interesting because when you look at digitalization, of course, you work cross-domain typically always, seldom that those technology providers only have customers in one segment. Of course, then we have in orange pulp and paper, green metals, light blue is minerals and mining. But then the lion part still is cross-domain projects, and the money, of course, pretty much is divided in the same way as the amounts of projects. So that's a bit about the money. And then I just wanted to connect to a few different projects that we are running. So when running the annual conference for PiiA just a few weeks ago, we had a few different breakout sessions directed to these different main areas, and we just looked at also. So for interoperability, we have one large initiative called Digitala stambanan. I think you mentioned that earlier as well. And that's great because here the DPP and traceability is one of the issues we are addressing within the digital value chains, mainly when it comes to steel. Then we have a project called Trace for Value. That's also an awful lot of partners where we look at traceability for sustainable value chains. And of course, together with SEIIA, we think this makes up a great offer and also a platform for people who want to learn more about how we work with traceability and the DPPs in particular to come in and be part of these projects in different ways. If we look at metals and minerals, of course, this is a big area for us and for Sweden overall, and there we also have a few projects. So I will not go through all the different PiiA projects, but if someone's interested, we can totally have a look at the different breakout when it comes to different companies and the applications that we're addressing in the company in the projects. Forestry and also chemistry are large investments also, and maybe above all forestry. Also here we have a lot of advanced production and process optimization. And we do see that we have more to do within the chemistry segment. I would like to promote a bit extra now the latest report by the PiiA Insight team about forestry, and that's called, well, Green Gold Digital Values. That's available so far in Swedish, but if we have a huge interest, of course, we can have a look at transforming that to English as well. Just to have another look at the PiiA Insight reports. This is some of the latest ones that we have. So we're addressing, of course, both the different branches of process industry, but also phenomena like when AI came into hype, then we made a specific report for how AI could be used within process industry. So this is sort of our report series where we try to share knowledge and insights that we scout within the tech industry. What does PiiA do now then? So we have spent pretty much all the money we have had from the financing agencies to run an awful lot of projects. But the program office now will still be around for 2 more years and trying to create as much value as we can. And that means that we need to look now into other funding opportunities and gather the stakeholders from process industry to look at other programs as well. Since PiiA is sort of coming to an end and we need to go somewhere else to continue these efforts. So from the board, a very strong message from the last meeting was that my task now, together with the other people in the program office, is to make room for process industry in the present programs, or the ones we're also starting now, because what we see often is that we have a discussion about manufacturing industry on the one side and process industry on the other side, and not always we are looking at the value chain, which of course is very relevant. So if we're going to talk about sustainability and scope 3 objectives, then when we need to look at the value chain, we need to start with the process industry, of course. So that's one very important thing for us to describe how the industry is positioned here and what kind of consequences manufacturing industry gets from process industry. And of course, there's these big efforts with carbon reducing activities is very, very important, of course. We also have a task then to try and see that new programs include the specific branches of the process industry. And we're also going to continue to gather consortia and create projects based on the needs of the process industry. So that's a continuous discussion that we have with the SEIIA people, and of course also with the other stakeholders in the PiiA program portfolio. So that's something that we continue. And now, of course, then we describe this as we help other programs to invest their money wisely, where we can then gather the stakeholders from the process industry and help them get to more funding. The funding agencies, again, a bit here, we mentioned Vinnova, Energimyndigheten and Formas, and some of the older programs now. So these 5, except for PiiA, are the ones we are mainly working with. And we also have Production 2030, which is a manufacturing industries program from previously. And I would like to mention a few words about how this innovation system in Sweden is changing. You need to stop me, Terese, when we go too slow here. But one very important program to just mention here is advanced digitalization. There, 2 minutes. I will go so much quicker. But this is like one of the important funding sources that we need to look at also from the process industry. Their budget, let's see that PiiA had about 50 million SEK a year. Here we're looking at 500 million SEK a year. So of course we should see to that this program also understands the beauty of process industry. And also going forward, there will be new so-called impact programs. There have been a few launched already, and there will be more going forward. So that's something we work with as well, especially within metals and minerals. And they are supposed to have a bigger target or objective than the strategic innovation programs had. They should work with system innovation, not just specific industry upgrades, so to say. I'm going to speed this now because we need to get to an end. So we mentioned a few projects that PiiA are involved in or coordinating already. And that's just from my side, an open invite. If you're interested, we're very open to add more partners, or just if you want to check us out, come to an open project meeting and see what we're up to. So I think I'll end my presentation there because PowerPoints are like so dominating when you look at a meeting. So just coming back to the Teams view and see if there are maybe any questions or things I should be addressing at the few last seconds of this presentation. So PiiA is a very flexible program, I should say. We're all up to do new things with new partners to improve how we work with digitalization in a broader scope of process industry. That's what we're up to, and that we hope to do together with you guys.
Thank you so much, Malin. And I think it was a great speed up presentation. It was so much information inside. Actually, I think we're going to share the presentations afterwards, and there are all the pictures. And we actually have one question for you. And it's how much value has been gained thanks to PiiA, and what kind of value? Very open question.
Yes, that's a very open question. You know, that's of course the most exciting questions of all. Our most cherry person for the board, he answered this question at the conference that we had in October, and he says that PiiA has been making the industry braver. I think that's a great feedback, but to capture that in a value of any kind of currency, that's very, very difficult. But that's of course what we hope to try and do going forward as well. And for me, it's so important that we can combine different kind of organizations in the same projects. I mean, projects are typically the tool that we have to make people engage in these challenges and bring the knowledge forward, and also to keep a decently open format so that as many as possible can learn from the results that we are getting. So that we can combine SMEs, large companies, academia, and that we from the program office help to do that. If we see that there's some capacity missing in the project, it's sort of our thing to try and add that competence to get the real value out. But of course, then, I mean, we do have a few reports on the values that we have been contributing to create, because, I mean, it's not us, it's the companies who are in the projects who are actually capturing the value in their processes or products or knowledge creation. We're just like facilitating, creating the arena for this. But we hope to be able to do that for a bit longer.
And we are so thankful that you do. And everyone that is interested can follow you on your webpage and on LinkedIn as well, I know. Thank you so much, Malin. Mats, I think it's time for a short break, or what do you say?
Yes, that sounds really good. I think we have set it as a 5-minute break now. We will have a little bit longer one for the coffee a little bit later on in the program, but let's start with some 5 minutes break that already in the Erik has started already. So you see the ticking clock goes down, and when it's down to 0, we start all over again. See you now.
Great. See you soon.
So, welcome back, everybody. Hope that you have a short time to do whatever you want to do. Next on stage, I will ask Erik to come back and also our Terese to join us. So, stage is yours.
Yeah, thank you.
Welcome.
Okay, when I had my introduction, I talked a bit about Digitala stambanan and the coming projects, and I will start to talk about general about the new project, and Terese will come into the details about our project. So it's difficult to translate Digitala stambanan to some good English word because it's a very Swedish thing, but skip that. What is Digitala stambanan phase 3? Yeah, it's a continuous project. We have run phase 1 and phase 2, as I mentioned in my presentation before. We have just ended phase 2, and now we're starting phase 3. And it's a very interesting phase we are in now because we're taking the good things from the last projects and make more details now around them. So it's really like continuously working of what we have achieved from the phase 2. And now we are putting the products in a more focus. We started with it in phase 2, and for example for SEIIA we looked at the digital product passport from a consumer view, and that's also where we met Christoph and have started working with him. So the phase 2 have been very good for the knowledge that SEIIA have achieved during this work. But we are now also working on more on the value system, putting this into a bigger scope. So that's some very interesting views on the new project, the phase 2 project, and we have had lots of new stakeholders also in this. And the role that SEIIA will have in the phase 3 project is to handle, not handle, but to represent the interoperability concepts and standards and so on. If you look at the project for it's a 3-year project. It's quite big budget, and you could also see what the organization that they are involved now. And I could just say, for example, SEIIA, they have been participating in a phase 2 and now participating in phase 3, and they are also now part of the European standardization for digital product passport. So that's, I think, is very nice because now we have more partners from the Swedish industry into this standardization work, and we could now continue also on this project to work together about, for example, the digital product passport, how they should be made and how should we use them in the daily work. There are different type of areas in this project also. To be aware of all of them, maybe you should be involved in the project, but the user interaction and I think what we have seen from SEIIA view is that we need to make a new how the management should work with this type of issues about the information exchange and digitalization, because you need to realize that digitalization are on top level, should be handled on the top level in the organization. So that's important to also work with in this project to announce these questions into the top management. And we had talked about digital product passport and all the regularity systems that follow of that. But also the focus on the culture change, and then that Terese will continue with to talk about our mission in this project is the culture change, where we want to continue our work, not maybe so much on the standards that we have worked with until now, but now we also want to address the culture change that we see that the industry need in the future. So from that, I'll hand over to you, Terese, to take the next phase of this presentation.
Yes, thank you, Erik. And I will talk a bit more about one of the work packages in Digitala stambanan that SEIIA is like extra involved. And actually the purpose of why we're doing this is actually to put the industry in the middle of the digital shift. We can all see that we are in a paradigm shift where digitalization, it affects all our lives, both privately and at our working places. And the industry in Sweden and internationally cannot afford to fall behind in this development. And we can actually see that there are very, very big differences between the potential about the digitalizations and how we actually work with them in practice daily in the industry. And now we want to address all of those concerns about digitalization of being expensive and risky and hard to handle. We want to create a cultural movement that actually make the digital development as a part of the daily work at the industry. And we think that one of the effects, and one of the biggest effects actually, is that it makes the industry more attractive for new groups, for younger people, for other people that have been involved before. So we think that we have a couple of steps in this work package that we need to do. And the first part is about knowledge and analysis. We know that there are a lot of papers, works, plans, roadmaps, visions around the sector, and we want to get a knowledge about those. We want to catch them all, like in Pokemon. We want to put them up and like read about them. We want to collect them, and we want to do like a joint knowledge view about the materials that are running around in the sector. And that can actually give us a good overview. And it's very important for us also to, during this work, get knowledge about the actors and persons that actually are involved in this foresighting project, so we can invite them to the workshops in the next part of the project. Because we want to collect people from the industry together to work in workshops to the purpose to try to exchange experiences and coordinate the directions of the digitalization work that is actually happening in the sector and maybe outside the sector as well. Where could we find the knowledge about the good project? How does it work when you got to get from the technical ways into the practical work? How do you make that changes? And the results from this work will be presented as a joint vision for the industry. And we will present the vision as, for example, websites, social media. We can do like webinars and films about this, just to try to show where we are now and where we want to be in a couple of years. And during this work, we will continue to collect examples of the work and like where could you find those good parts to show as demonstrations. And like during this process, we will also be able to build stronger and more connected networks between the actors that actually need to know about each other to get ahead to work as a stronger foresighting persons. And in the third part, we are going to work with those demonstrations and show them like a concrete example of projects that the industry have already made, or like industries quite close to this process industry have made, so that they can be inspiring for the ones who want to be working with those methods. And we'll have them in different formats. For example, this is just examples, webinars, conferences, it could be like industry visits, and actually it might be business coaching as well. And depending on the format, we will invite relevant participants from the industry to join, and many of the activities are open to anyone who is interested to join. So the point of this is that we are looking to create and show inspiring examples. We want to make a joint vision for the industry. We will create stronger networks, and we will build up bigger competence about digitalization in the industry. And we actually think that this can give courage to develop the industry. And we want you to join us. So if you are interested to join this kind of project, just send us an email or look at the website and we will give you more information. And I also can say that we are actually really in the start of this project. That's why these pictures might be a bit fluffy still. And this will, of course, be built up like step by step, really controlled activities that you will be able to read more about at our webpage. So I think I'm finished there.
Thank you, Terese. That was
Thank you.
very good. You was talking about joining this project or participating. If I'm interested, how do you do? Is it going to be that you're looking for people who are spending all their working time in this project, or is it a certification of part-time, or what's the, how do you see that?
Actually, it's possible to join as much as you like to. If you have a lot of time, of course, we are really happy to have people that is really dedicated in the project, but also it's absolutely completely okay to just join for a couple of hours. You can be in the reference group, or you can join as one of the bigger parties to join the project. So just send us an email and tell you about the role that you want to have, and we will try to find a space for you.
Yes, but and also you talk about demonstrations. If I want to be a part of that, or if I think I have an idea that can help the project out, will it cost me something, or how it?
No, it's possible for you to join like with your time, and we will count that in like one of the feeding into the project as well. So you don't need to spend money in it, but the time is important for us.
Good. And at the end, will it be physical meetings? So in this case, where in the country will they be, or will they be digital or hybrids, or?
All of the ways. It will be like in different parts of Sweden, and it will be digital, and sometimes it will be hybrid meetings.
Good. Thank you.
Thank you
Very much for that. Do we have any more questions from the audience?
Not at the moment where I can see.
No, doesn't look like that. In that case, we thank Terese and Erik very much for that presentation. Very interesting to follow that. And next up is Peter Axelsson. So welcome, Peter.
Thank you. I hope you now can
We can see
my
it.
screen.
Yes.
Yes. Well, thank you very much for having me. I will present a project that is from, let's say, a neighboring industry, from the built environment. We have similar problems. There are some small differences, but we also have a very good cooperation between our different research projects, I think, which we have been able to utilize in a good way. So this project is called Interoperability, or Digital Collaboration for the Built Environment. So what are our main challenges? Well, the built environment is, when you look at the life cycle, it's a lot of different stakeholders, different processes, everything from early planning. In the municipalities, we have design process and the actual construction and operation, maintenance, and in the end demolition and renovation. So it's a real rather complex life cycle and environment where many different actors come in, and they have different processes, they have their own standards, if they have standards, and we need to have a better way to work between those different sectors within the industry. And in this project, we are looking very much at what we call geodata or geographical information. We have building and asset data, the BIM data, and we have the product data and also the operational data that comes into the process. So this project has been running for 1 year now. It's 19 participating organizations, and we have a good mix of companies, academia. So I think we have a good mix in that sense. And when we talk about digital collaboration here, that what we mean when interoperability can mean, when you try to explain it to people, it's quite difficult. But if you use the word digital collaboration or digital samverkan, it's easier for people to understand what we actually mean. So it's across technology and business areas. And what we're looking at here, as I said, mainly spatial data, GIS, construction data, product data, and operation maintenance data. And we look at different ways of doing this, mainly with using ontologies as a technical platform and linked data techniques, semantic web, and knowledge graphs, which I will come back to in the presentation. So you can ask, is there really a need for another project on interoperability? There are so many different initiatives and projects. And when we look at specifically for our sector, if we start on what type of governance we have here, or we start on the European level, we have some of this has already been mentioned here, and this is where we have similar challenges, I would say. On top, we have the Fit for 55 climate law that then comes down to different other regulations. We have the European Interoperable Act, which gives some how the systems should be constructed, really, especially on a government basis, to be able to be more interoperable. And we have the CPR and the SPR that then comes down to the digital product passports that we have also heard about, which is an important issue here. On the national side, we have quite a lot of things coming out from DIG. We have the framework for digital collaboration, something that came up last week, which I think should be interesting also for SEIIA, is the interoperable specifications profile. That is a new initiative that started recently. And there are many different kinds of investigations that goes in this direction. So we have some governance policies, and then we have the enablers, which in this case are very much the different standards that guides us in how on different levels. It's both in the processes, information models, down to formats and classification, identification, and very much then on the environmental data and product data recently. And when we have the realization how this shall be done, it's also on different levels. We have on the European level with the Interoperable Europe and different development and projects for public activities, both at general level and also specifically for the built environmental sector. But we see that many of those projects are not really looking at the issue from the built environment viewpoint. So we see that there is a need for a project that is based on the needs and conditions of the built environment industry. And this project is then run through one of the other innovation programs, Smart Built Environments, similar to PiiA, but with a focus more on the built environment and the processes. So when we talk about interoperability, it's not just about the technical interoperability. We also have the legal part, the legal interoperability, which is often something that even if we have good technical solutions, there are so many different legal obstacles that you can get stuck on. So this needs to be addressed. Sometimes we can change part of this, but very often it's regulations on a European level or even a higher level. So those problems are really difficult to handle. We have, for example, when we have public clients in Sweden, like large infrastructure projects, you're not allowed to store information in cloud-based solutions, which then stops all the technical parts down here. So unless we solve those legal issues, we can look at those technical solutions, but we will never be able to implement them in a good way. Same goes with the organizational interoperability, to find good processes, how to work with those issues. And then we come down to the semantic interoperability, that is to really understand what we mean when we say something between different sectors or industries. And then the technical solutions, how to implement it in a technical framework. So we are looking at all those 4 parts of interoperability in this project. And we're doing this very much in the same framework as the European Interoperability Framework, which is a framework that was developed a couple of years ago. And below that you can have different national frameworks. Sweden has developed one by DIG, and you can also have what's called domain interoperability frameworks. So our project is really somewhere here. We look at the structure that we find in the European Interoperability Framework, so that we don't make up something completely new, but we try to follow the same structure and ideas that goes from the top down to the national, down to domain specific frameworks. So when we look at a typical project in the built environment in a life cycle process, we have maybe 5 to 30 years when we have from concept development and production, and then we might have an operation phase that goes from 70 to more than 100 years for some assets. Like a typical bridge, for example, maybe have a lifespan of 80 years or something like that. So it's a very long time that you have to keep all this information in a good way. And the construction phase can be also very long. We have the large infrastructure projects like Bypass Stockholm, for example, which is around 25 years in total. And in the early phases of those projects, we have typical what we call geographic information. That is information how it looks like existing values for the environment. And when we start the development, we come into more construction data, civil engineering data, which then form a basis for the solution that will be built. And we have production data where we actually put in some of those products when we construct the assets. And we have the operational data, which then is very long time span here, which builds up more and more information. And of course, during all this life cycle, we also have reinvestments that more or less start again from the beginning here. So the project is very much how do we get a better communication between those different types of data that we have in such a project. So the main deliverables are a framework in the form of a publication. It's not a PDF publication, it's a web publication that will be sort of best practice and for a framework, how to have a good digital collaboration in project for the built environment. And here it's based very much then on the structure of the Swedish framework and the European framework, and also the European interoperability framework for smart cities and communities, which is this one here, which is quite close to what we are looking at here. When we look at the technical implementation of this framework, it's mainly based on linked data, semantic web, and knowledge graphs. And we think that this is maybe the technology that gives us the best way of communicating between different standards, different semantics, and doing this in an open way instead of trying to build APIs or document exchange and so on that will not give the same flexibility. So we have in the bottom here, we have this project, and then we have the governance part, which is the framework for digital collaboration. And we have the technical platform based on ontologies and linked data. And then we look at those four different perspectives, the legal, organizational, information, and technical. And on the technical side here, we look at for the whole life cycle and try to include those kind of data from geographical BIM data, product data, and operational data. Then, of course, there are a lot of other things that you need to look at, but that is mainly it's something that needs to be connected, but it's not really part of the project, and that's all security issues, financial data, and we have links with other frameworks, projects, and initiatives as well. One of the storylines that we have been looking at is Kista Äng. It's a development area outside Stockholm here where we have different kinds of data. It's not built yet, but we have different detailed plans and different kinds of information. And here we can then build up a knowledge graph. We have one use case here where we're looking at city trees that are planted, how they are planned, where they are situated, what types, and how they affect the environment and so on. And when we talk about ontologies and knowledge graphs, what's the main concept of a knowledge graph is when you have an ontology that is the information model really, and combine it with data, then you have a knowledge graph. So using both an ontology for defining things, the semantic part, and then putting the data in this model that creates then a knowledge graph that can be used with graph technology and graph databases to communicate. And we have different actors like the public, we have the client, which in this case is the City of Stockholm, principal contractors, and then more specific contractors for design, environment, and so on, and then the construction companies that will build it then in the end. And when we look at how to create a knowledge graph, there are different ways of doing this. You can build, of course, a graph database directly, but there many times you have data in other forms. We have, for example, 3D city data in a database. This is something that the University of Lund has been working with. And this is a relational database. And on top of this, you can do a virtualization with a tool here that is called OnTop. And then you can then use those standard technical tools to ask this. So this becomes then a sort of graph database directly here. And those tools here are standard tools that is defined by the W3C community. So those are all standard and open standards. You can, in some cases, we also have other forms like XML format where we have CityGML or JSON files, and then can also be lifted with different tools. There is one tool called RML that we have used a lot, and then that information can be lifted also to a database, graph database. And we can also then use other external knowledge graphs that already exist, which is one of the good parts with this technology, that you can add different sources in a very simple way. So when it comes to this use case where we look at the for city planning here, we have had a detailed plan that exists in GeoJSON format from the land survey, and this we can then transform to an ontology and produce an knowledge graph in that sense. And then we can use the standard tools for communicating with that data source. We also have a 3D city model in the form of a CityGML, which is also lifted to with this OnTop methodology to so we can ask in the same way. And this we do with the other parts here as well. We have product data here in the form of similar to digital product passport, or as far that standard now has come. I mean, it's not everything is set here, but here we have the help from Jönköping Technical University. I think I saw Rahel on the list here with people, and so they are looking at how to expose this kind of information in the form of an ontology or a knowledge graph. And then we have other standard ontologies, and especially here we have the upper ontologies to how to connect those on an upper level, where we have different discussions here. In SEIIA, you are looking very much as the IDO, but there is also an European standard here that maybe is more suited for the built environment. So a typical use case where we talk about, for example, climate analysis, we then have a knowledge graph here. And if we want to ask to give me input data related to trees for climate analysis, it could be for wind analysis or whatever, then this can then go to other knowledge graphs that can be located in any other place, of course. And since this is all based on the same standards, you can see this as a very generalized form of an API. So you don't need to know how those look in the different places. You only need to know the address to the endpoint of those knowledge graphs. So then you can ask for information here from the detailed plans and from the 3D city model or some general ontology knowledge graph for botanicals, and then combine this into an analysis result here that in turn then can go back to this project knowledge graph here. So this is just an example of how you could use those different sources to combine the information coming from different sources and different standards into a more common framework. So you can see those ontologies and semantic operability as we have a lot of different standards here. They can be lifted to ontologies, and we can then combine them with what's called alignment ontologies to be able to talk to each other at least on an upper level. And here there are some different upper ontologies that we are looking at, and it seems like we are ending up in this one, the European Standard 17632, or the IDO, or a combination of those two in the end. And this makes a sort of implementation of the Babelfish that you might know of. So I think that ends up my presentation here, and thank you.
Thank you, Peter. I have a question for you, and it's like, if you look into the future, how do you think or hope that the building sector will work with these interoperability questions in about 5 years or so?
Well, I think there are several issues that are high up at the list that we are working with now. It's very much with the machine interpretable requirements and also machine verifiable deliveries of information, because today that is a very low automation on those issues. So we need to be better to write the requirements for different, like an infrastructure project. We need to be able to formulate those in more machine readable form, and also to make the deliveries then be more automatically verified when they're delivered to different ends. And I think that when we look at ontologies and linked data, that is one way of doing it, and it's getting quite a especially on the European level, a lot of information is exposed as what's called an RDF data or linked data, because it's a very convenient form of exposing data, since it's you don't have to define the APIs really, because all that information is built in within the actual knowledge graph. So you can define both your information model and the data, and so with the same concept.
Thank you.
Thank you very much, Peter, for that. Very interesting. Do we have any more questions from the audience? Have you seen anybody, Terese? No?
No, I haven't seen any more questions from the audience. I have one more question if we have the time.
Yeah, we can take one. Short one.
Yeah, and it's just, how do you think in the future, will it still be 2D prints, or should everything be digitalized in the future?
Well, I think you could say that everything should be digitalized, but that doesn't mean that we won't be using drawings in 2D or 3D models or Excel sheets or whatever, but it should all be based on the same sources, so that we don't have parallel production lanes where some do the drawings and some do the models or whatever it is. But I think we will use drawings in the future as well. But the important part is how are those generated and where's the data coming from, and it should be the same sources independent on what kind of visualization tool you're using.
Great, thank you. I think that's a great thing to have in mind during the next part of the program, so there's actually a break, isn't it?
Yes, of course. We have announcement of a little bit of a switch in the agenda. We'll now have a 10 minutes pause for coffee or whatever, and after that it's Peter Townsend's time to join us. So see you in 10 minutes, and then comes Chief Host Peter Townsend. Thank you.
Hey, Erik. Can you hear me?
Yeah.
Hi, Erik. It's Melinda. Sorry, I'm just trying to catch up. It's 10 o'clock at night here in Perth. Have you rescheduled me to later?
And maybe we should have some wrong in the mixed up the time.
I was due to follow Peter in the program I have, Peter Axelsson.
Yeah. Okay, maybe that we have changed. We have mixed up the time schedule then.
Yes, but
it's already quite late here.
Yeah.
Yes, I understand.
But if we have Peter and Heiner on the call, is it okay that we take Melinda before DXB and CFOS?
Yes, I think. Hi, Melinda. Good evening.
Hi, that would be much appreciated, Heiner. I've been up since 5 o'clock this morning. I don't think I would be able to wait for another hour just to give my talk. I'm afraid I'd go to bed.
I think you can start, and then Peter should follow, and then I would be the third. Right.
Oh, Heiner, that would be amazing if I could do that.
Yeah.
Of course, we'll fix that for you.
Okay. Thank you very much, guys.
Only Peter should know it. Yes, but he's there.
Peter is in the call also. It's okay, Peter.
He may have gone for coffee, but hopefully he won't mind.
Yeah. But he will have the same time, so it's no problem.
We sort that out.
Okay, thanks so much.
So, welcome back, everybody. Hope that you have a nice break. We have a second change in the agenda. So, directly now after the break, I will let Melinda into the stage. So, very welcome all the way from Australia. I know it's really late in Perth where you are. And yeah, welcome. The stage is yours.
Thank you very much, Erik, and thank you very much, everybody, for inviting me. I'm just going to try and share the screen and see if technology does its usual wonderful thing. Hopefully so. Erik, am I sharing?
You're sharing?
And can you see full screen mode?
Not yet, but hopefully quite soon. Try to press it once more.
Okay, I'm just going to go back, sorry, and we're going to try again. Right, sorry about that, guys. It's late here. Display setting. Right, how are we doing now?
It's still not in presentation mode.
I'm swapping back. Okay, what is that doing? Not yet?
No, sorry.
Okay, I'm just going to, in the interest of time, I'm just going to show it. Can you see it? Can you see the screen without it being?
Yeah, we can see the screen,
mode?
but it's not in presentation mode. But you can keep it this way.
I'm just going to do that.
Yeah.
Yeah, just in the interest of time. So, thank you very much, everybody. Welcome, and thank you to SEIIA for this invitation to present. And I'm going to talk about IDO, the new ontology-based interoperability, the why, the what, and the how. So I know IDO has been mentioned in the previous talk, and I know some of you know, I can see people on the screen who I recognize have been involved and know something about IDO. And I'm actually going to try and cover both people who don't know anything about it and people that do know something about it with some new and slightly more personal perspectives. So I was on a plane yesterday. I had a 5-hour flight between Brisbane and Perth. This is how big Australia is. And I was sitting next to somebody and I was working. I worked the whole trip, and about an hour before we landed, we got talking. And I said, well, I'm a reliability engineer, and he said, oh, I work for AWS. I said, oh, that's interesting, Amazon Web Services. And it turns out that he's the head of solutions architect for mining, energy, and Australia, and industry for all of Australia for AWS. And we went a bit further, and I mentioned that I was working on ontologies, and he just looked at me and he said, why is a professor of reliability and maintenance engineering working on ontologies? And it actually got me thinking, and my first slide here is to try and explain to those of you on the call who are not engineering enterprise architects, but maybe domain engineers in regular roles in design, in maintenance, in operations, from my perspective, why this is something we need to know about. And we need to be involved in and supportive of. So the first thing that came to mind as I was trying to explain to him was because in my world, in maintenance and reliability, quite often problems with equipment have their inception way back in the past. Either something that happened in design or something that happened in a major event or a major repair in their lifetime can often be very informative to understand what the problems are now. In the past 5 years, it has rapidly transformed forever the ease at which we can get information out of unstructured text. I have been working a lot on an area called technical language processing. This is like natural language processing, but it's for engineering data. And the tools and the processes have come along in leaps and bounds. It's quite extraordinary. And and the team I work with has done a lot of work in extracting information from maintenance records. This is now almost, in my mind, routine. This is largely a solved problem. You can get the data out. The question is what you do with it. And for this, what we do with it, this idea of having an ecosystem of ontologies is, I believe, really necessary for semantic data exchange at scale and between data models with different schemas, which is kind of the norm. I'm a little concerned. I've done a lot of work, or people I work with, because I'm not a subject matter expert, do a lot of work with knowledge graphs. They're fantastic. I've heard lots of good things about them. And there's much that's very attractive about them compared to relational databases. But to be really useful, they still need schemas. But if every Tom, Dick, and Harry creates a knowledge graph from their data and they all use different schemas, we're going to replicate a lot of the problems we kind of have in relational databases. As you know, if we want to exchange data between ourselves, between other people in the same discipline, between other people in different parts of the life cycle, and between people outside our organization, exchanging data just based on labels in columns is incredibly problematic and not scalable. And ultimately, as engineers, we have, I believe, and mainly probably because I'm a reliability engineer, that the things that we do in the way that a lot of our processes work, we need quality control. We need to, and that goes for everything we do, including how we exchange data. And certainly some of the examples I'm going to give you tonight are more about, you know, processes where you can actually do checks, provided you have sensible ontologies and you adhere to them. It opens the door to being able to do quality control. And I think that's very important for engineers. So what I'm going to do in the next kind of 13 slides and, you know, 15 or so minutes is try and give you both a flavor of what this is. I'm not going into the details, but I can provide you links, and the slides will be circulated, and there's lots of links on the slides. If this interests you, please do follow up with us, and we'd love to talk to you. So in the why, the what, and the how, the what I'm going to talk about is this industrial data ontology. It was mentioned by Peter Axelsson in his in the talk preceded this. So, you know, what is this? What do we mean by this? And you can read on the screen, as well as I can read it to you, that really it's an ontology. It's designed for the management of industrial data. It enables you to build vocabularies and manage asset models that exploit these reference data libraries that also Peter mentioned, and use this reasoning, this OWL ontology web language, the OWL language description logic. We have been developing use cases for it in all phases of the life cycle. It's no secret that the initial motivation for IDO has come out of the requirements end of the life cycle, and it's done a lot of work that I'm going to touch on about using it at that front end part, especially in the relationship between the EPCM, the engineering procurement contractors, and the asset owners, and now increasingly the vendors. But my interest is at the in-service phase of the life cycle, and we've demonstrated it has some very nice use cases there. There is quite a bit of information online. Probably one of the big developments of the last 2 years is it has progressed. In fact, just this month, it has now reached what's called the DIS, or the Draft International Standard stage of an ISO standard. So for people in regulated industries, and for people that need to be using as part of contracts and the like standards, the IDO will be an ISO standard, we hope late, I think, next year. The group that has carriage of it is the quickly named TC184SC4 Working Group 26, and it's run, the project manager is a Norwegian, Paul Rylandsson, and if you need information, please get in touch. And this is a small, IDO is not a very large ontology, deliberately small top-level ontology. It only works with other ontologies, and I'll explain that in a minute. But this is just to give you some idea of what some of the top level classes are. Now, I find explaining ontologies both to when I started and to try and get to grips with this, when I try and explain these to my peers, I have ended up with this, what I call the Lego analogy. And I, again, drawing on my engineering roots, you know, if I want to make something, a model, and I want to make a small physical model, you know, it's very easy to make that from Lego. You go to the box, you pick out the parts you want, you put them together, and they all fit together. And in a way, I think of, and if somebody else wants to make something else, they go to the same box, they pull out their parts, and then they want to connect it to my part. It will work because we're all working with Lego. And in a way, I think that's what a top ontology does for you. The top ontology is for me like some form of specification about the size, shape, and design of the Lego bricks. And if we all adhere to that specification, we can build whatever we want, as long as, and we can make our own bricks, but the bricks have to comply with the specification. And if they don't, and you try and put them together, they won't fit. And this is what we mean by reasoning in this analogy. And there's an increasing number of these Lego bricks available. In some cases, there's whole subsystems of Lego bricks that if you want to build, you know, an aircraft, you can go and get one of the wings, for instance, sort of as a general idea. And so entire modules can be reused, but also individual classes can be reused. And the two figures there on the top kind of show you some ontologies I'm going to show you later. The one on the left, which is around valves, just talks about importing entire modules in order to do valve design specification. The one on the right is a project that I'm working on right now, and you're not supposed to be able to read it. The colors are what are important, but this is building an ontology to check failure mode classifications. And in this case, I'm using classes from different ontologies. The white ones up the top are IDO, the yellow ones are a Vermeer ontology that's public, and the orange, purple, and blue ones are ontologies I've made of international standards that I would make available, and then these would be reusable. So I'm in fact creating Lego pieces or Lego sets here as well. So think of it as an ontology as a specification, but for data. So how do I think this works, and what is one of the big motivations? So this is a new picture that I made last week. And what I'm trying to show inside the cloud at the top is what we're going to need as an industry sector is an ecosystem where we have a set of open, shared, managed models and tools. In this ecosystem, the kind of the specification part is the blue part, which is the industrial data ontology. But that alone, you can't model stuff just with the IDO. It's too high level. In order to make it relevant, you have to bring in these domain independent reference ontologies for things, and I'll show you on the next slide what I mean by that. You have to have these modeling patterns. It's almost like little subsystems that data modelers can reuse, so that every time you model something that's the same, something to do with sensors, the same patterns are being used, same modeling patterns are being used. You don't rely on, you know, every software engineer to make up their own how they're going to do this. That just leads to chaos. And you need a library of templates for common modeling patterns. So in some cases, these patterns will represent things in standards that we all use, and some of them will just be things that we model a lot. Those can then be pulled into a workspace, a shared space, so to speak, between different players. And in this case, I've chosen to talk about an operator, a vendor, and an EPCM. Each of these organizations has their own databases. They have some form of graph database, and there was an illustration of that in the previous talk. They have their own linked data. The yellow color I've kind of used to indicate things that are internal and private and confidential to those companies. However, they can draw down from the pink layer things they need to do their work and push things back when they're finished with them without exposing any of their data. So think about being able to do this as you, for example, hand over information between an EPCM and an operator, or you want to exchange information between a vendor and an EPCM about, for example, a valve product. Does that meet the valve specification? This can happen by using the common terms and data models in the pink layer. And it's also informed by linked data. The ontologies themselves need obviously a fair amount of individual linked data, for example, to describe parts of pumps and things like that. And those also sit there and can be drawn in and used. So to do this on your own, you know, one of the dangers is you get a company, they just start off on their own to do this. But really, the huge value is in being able to do this across the value chain, and to be able to exchange data, semantically interoperable data with your other parts of the ecosystem, business ecosystem in which you operate. Just to try and put a bit more meat on the bones there, I've provided some examples of some of the things inside some of these boxes. So at the bottom, we have the industrial data ontology. One of the issues I see is that lots of people decide they're going to make a top ontology or what they call a top ontology, and that's all very well, but as I mentioned, you can't actually model anything with a top ontology with just a few terms. There's just too many things we have to model. And one of the things that the IDO community, and there are other communities as well, have done is that we have these domain independent reference ontologies. So we already have an ontology for information artifacts, ontologies for units of measure, which by itself is a huge piece of work, ontologies for time, geospatial sensors and others. So what one wants to be able to do is to be able to appropriately reuse either terms or entire imports of things that describe things in general. You don't want to have to make those up. They take an enormous amount of time to do properly. And this should be a shared resource for us as an industry. And we're already making quite a bit of strides there. There's a community called BFO, Basic Formal Ontology. They have done a lot of work in this area, but other communities like the Semantic Sensor Network, the Units of Measure group, there's a lot out there that can be used. On top of that, we also need to have ontologies that we can reuse that represent processes that are domain processes. So in my area, we've been responsible for making a maintenance ontology. So this contains most of the terms you might need to use to represent a relationship between maintenance activities and failure processes and things that happen in the maintenance management system. There's also a procedures ontology. There's a failures ontology. There's a scheduling ontology. There's a growing community of things that if you're going to work in and your data is in this domain, you can probably save yourself a lot of time by going and finding work that's previously been done, provided it's documented, annotated, available, has a high FAIR score and the like. So there's a certain amount of checking that needs to go on, but we need to encourage more of these to come forward and be put in public-facing areas. An increasing area of focus has been, how do we extract and represent as small ontology models really important information captured in ISO, ASME, API, and other standards. And there's been quite a lot of work done recently by a group called ABLE in Norway about representing certain tables in important standards relating to piping and valves that is really useful and reusable. And I've certainly done a fair bit of work in trying to represent information that's available in a standard called ISO 14224 and the functional hierarchy of IEC 81346. On top of that, it's not stopped there. There's lots of things that we model over and over again, like how do we model quantities and units, functions, streams, features. I don't want everybody starting from scratch when they do that. Those little building blocks are very subsystems of your data models. Those need to be consistent, and we need to use repeatable patterns. So that needs to be part. So part of this is we can't, as a community, this is something that we should be thinking. If we're going to use these, we have to put in and take out. We have to have a way of growing the pile here so that it's easier for everything. On top of this, we need to have this open, shared and managed linked data reference libraries, for example, for equipment libraries. And then organizations themselves will want to develop things that are just used internally. And that's a separate thing, but it's outside of the ecosystem, but it's an important bit to remember, to have the capability of. So those are the things I think need to be in the IDEO ecosystem. What I want to do now is just briefly talk about some IDEO use cases. So, because I wasn't sure who was going to be in the room, I've got one on equipment specification, so that's the front end of the life cycle. I've got one on maintenance. I'm going to just mention one on scheduling, and I won't talk about the shared data model for automatic verification of precision measurement between Grundfos and Siemens, because I've actually put links on that. That was a published paper last year, and there's an article on it. So if you'd like to go and find out more about that, please look at the references. So for those of you who haven't come across IDEO, the first thing to say is this isn't some weird and wonderful academic project. This is, it exists today. It's being used in industry. It's actually one of those things that's really taken it's been worked on for about 20 years now. So it's sort of the 20 years, journey to overnight success. Probably one of the first major use cases that really got people's attention, it certainly got my attention, was the ABLE material master data ontology. This was used in, the funded for this came from Equinor. It was built by ABLE and DMV as part of the Jonas Sverdrup drilling platform, and the ability of the ontology to deal with quality control issues, duplication issues, and so on and so forth, led to some very, very substantial improvements in quality control and reductions in cost. And of course, the ontology wasn't just used for that, it's been able to be reused for subsequent engineering design, which is very exciting. Currently, there's a fairly major project, and I'm really pleased to be involved in it, again, with Equinor, ABLE, DMV, and Aker BP, I think. Apologies if I get that wrong. There are a couple of Akers. And basically what the goal of this is around valve specification. So as you can see in the corner, a single facility can have, 3,800 valves. They cost a fortune. They come from an amazingly different numbers of types of valves. There can be, 54 design piping specifications and 1,700 design material numbers. And every one of these valves has to be, individually sized and checked, because this is a high hazard facility. And if any one of them, leaks or fails, you can have major problems. And historically, this has required very highly trained, very experienced engineers who trawl through PDF documents and design sheets and piping specifications and standards and material data sets to produce valve design specifications. And then they have to get the vendor details, and then they have to go and check, does the vendor product match the design specifications? And does the valve design specification, is that appropriate for that particular valve in that particular location with that particular fluid in that part of the plant? It's an incredibly costly exercise So there's been a fairly massive effort over the last 3 years to actually make what we call the valve ontology. And this is, I appreciate it's a very busy slide, but what I'm trying to show you here is that starting from the left, we have these sort of modules like the valve collect module, the valve industry standards, the module. This brings in information from, you know, API 6D and 1634 and various other standards, the information we need. Those are the reference ontology and modeling patterns from standards. It brings in domain independent reference ontologies. It all aligns with IDO. And when we do that, we can, when we suck data in from the various, for the individual data to the ontology for that particular instance of a valve, we can use automated reasoning in order to check that the valve is compliant. The valve with that fluid at that pressure and temperature with that class is compliant with all the material, piping and valve specifications that it needs to be compliant with, and that check can happen automatically. This is a really exciting proof of concept, and we are currently in the process of doing a number of presentations on it. The main person to talk to about this, if you're interested, is Anders Jervel from ABLE, and we are going to be preparing a paper, I hope, that will have more details about that. So that's kind of the design end of things. In my world around maintenance, we have some work which you can find online, both in YouTube and GitHub and in papers, an open access paper, which basically uses technical language processing to extract information from tables in maintenance procedures into an ontology, and a picture of the maintenance procedure is on the left. It pulls out that information, and then it does checks to see that the procedures are correct, complete, and consistent. And to make this procedure ontology, we didn't need to build a whole lot of new classes and relations, object properties, because we were able to use IDO, import the maintenance ontology, and just make the procedure parts that were not, that we needed for the project, which was a much quicker way of building a much less validation effort, because we're not recreating things from scratch. We're really reusing modules that are already there. And I think that's a big message about this, but you can only do that if somebody's made the module and they've made it available. Moving on, one of the really exciting developments in the IDO community is the addition of this IDO compliant scheduling ontology. This has actually been in the works for some time now. It's now moved into the ISO process, and it's essentially a collaboration between a number of operators who do scheduling around the Norwegian or offshore shelf. I'm not quite sure exactly what the wording is. And you can see what, you know, every one of those groups uses a different type of project management system. And you can see the view of Equinor, the guy lying there with his head under his laptop. It's kind of the pain that they're in right now. And the idea is that by working with a common scheduling ontology, that that integration and communication about schedules and changing schedules will be much more seamless, providing all of the players and stakeholders comply with the ILAT standard. And if you'd like some more information on that, please reach out to Lily and Hella. She is the project manager for Part 100. So SEIIA, as you can see on this screen, has been involved and is supporting IDO. I'm not sure if you've already heard from some of the SEIIA people about some of the use cases. I'm aware there's a pump use case, but there's really quite a growing community around IDO, which obviously is fantastic. If you want to know more about the standard, there is some information on the POSC-SEIIA ontology website, which is the upper of the two links there. But more importantly, I would really encourage you to watch some of Dirk Walter's videos, we've been releasing some training videos about IDEO, like what is it, what's the model, both technical and kind of use case videos. And I'd really encourage those of you who want more information to look at some of Dirk's videos. They're really well done and they're really insightful. So in closing, you know, what is the value proposition? That's what we're always asked, you know, what is the value proposition for this? So the why is essentially, and I hope I've given you just a sense that you could significantly improve productivity. A lot of the things around the requirements about the valve design specification do just that. Also in terms of managing maintenance procedures, these things are just manual and require quite well-experienced people to do. And if we can at least semi-automate that, that's a big step forward. The ontology is scalable. You do something once, every time you need to do it again, you do it again. It's scalable. As a result, the outputs are reproducible and things are in a standardized manner. You know, for engineers, this is in my mind, this is what we're trying to do. And why now? Why should we be investing our time in IDEO now? And this gets back to my conversation with the AWS guy on the plane. It's because all the parts, it's technically this is possible now. In the past, there were lots of kind of issues. The technical language processing and the way we can extract information from unstructured text that's new and that's fantastic. We now have knowledge graph. We've got knowledge graph software. We have IDEO, we're going to have an ISO standard. Yeah, a lot of the barriers have gone away. The second thing is really can't go on as we are. We cannot go on continually to manually do these things. The potential for human error is huge. A lot of our, you know, gray bearded, I've worked for 35-year guys, they're leaving and they're retiring. We have to support the next generation to do this work in a effective and safe way. I think we have the right community. We've got lots of really fantastic groups involved. But we need more resources. We need more funds to pay the ontologists to do this. We need more ontologists. We need more training. We need more infrastructure, and we need to get the software vendors involved. So the journey is not finished. And I really hope that this talk has kind of encouraged you, if you're being unfamiliar, to learn a bit more. If you are familiar and you're not engaged, to get engaged. And if you are engaged already, thank you very much. And I'm now going to do the usual thing and say, if you do have any questions, please call somebody else. That would be Paul at DMV, very close to you over in Norway. But I hope that this has given you some ideas to think about. Thank you very much.
Thank you so much for a very interesting presentation.
Yes, thank you very much, Melinda. I'm also just want to say that I'm really proud to be a part of this IDEO through SEIIA and the Digitala stambanan part 2. So that feels really great. We have some questions from the audience. From Peter, are you with us? Axelsson.
Yes. Yep. I thank you for a very. It was very good presented, the ideas behind, and so in a very good way to understand what we want to achieve actually, because that's always difficult to come down to. But I wonder if you are familiar with the upper ontology, the EN 17632, and if you have any comments regarding similarities or differences. I know we have, I don't know if you know Torbjörn Holm, who is involved very much in SEIIA. He's also within our project, so we have a good link there, and so we have discussions regarding those two upper ontologies, which one to use, or maybe we have to use both in some cases. But if you had any knowledge of, or if you have looked at that, it would be interesting to hear some comments on that.
Yeah, thank you, Peter. Look, I haven't looked at that specifically. I have, however, I do quite a lot of work with BFO. So I sit on the basic form, I sit on something called the Industrial Ontology Foundry Technical Board, which is more for the manufacturing sector. So this is an industrial ontology for the manufacturing sector, whereas IDEO is much more an industrial ontology for the process industry sector. And there is much in common between those two. I don't specifically know about the EN standard, but one thing just to mention to you is some years ago, back in 2018, the IOF community, the Industrial Ontology Foundry community, had to choose to align to one of three upper ontologies: BFO, Dolce, and the PSL, Process Specification Language. In looking at those, we came up with a series of questions about which upper ontology. If you feel like you might have to choose, you should maybe get in contact with me and I'll see if I can dig out what those questions were. Because it helped the IOF community decide on which of those upper ontologies, and they're to do with maintainability, usage. There are a whole bunch of really sensible things that might help your decision, and I'm happy to send that to you.
Thanks.
If you can get in contact with me.
I think since it's come up as a European standard, it's kind of difficult to move away from it, since it's also very much for the built environment sector. So it's
yeah, and I think there are all sorts of things to look at in terms of what their ecosystem is like, because if you're just starting with one standard and no ecosystem, it's going to be a very long haul for you.
Well, thank you.
Thank you very much, Melinda. Thank you for participating, though it's really late, like I said before. But yeah, once again, thank you very much, and we wish you a good night.
Okay, thanks everybody. Thanks for listening.
Thank you. So that takes us back, and that takes us to Peter Townsend. Are you with us?
Yeah, yes, I'm online.
Welcome,
Can you
Peter.
see me? Yeah.
Now we see you.
Yeah, it's a little bit dark in here. Sorry. Is that any better?
Yes, that's better. Thank you.
Yeah.
So the stage is yours, I guess. Welcome.
Right. Okay, I'll just share my presentation, if I could. There we go. Can everybody see that?
Yes, but it doesn't look like presentation view.
There we go. How about that?
Perfect.
Okay. All right. Well, in the interest of time, I'll get started. Yes, my name is Peter Townsend. I am the project director for CFOS. And today we're just going to cover over a little bit what is CFOS, why CFOS, then talk a little bit in depth about version 2, which was published at the end of October, and then just a little bit about implementation and how implementation is going. So just as a reminder to those that are new to CFOS, it stands for Capital Facilities Information Handover Specification, and we like to pronounce it CFOS. And our purpose this is our purpose statement, is to create a handover specification that really is practical, and it can be implemented right across the supply chain. You know, from the owner operators all the way down to the equipment suppliers, for the information that is required to be handed over at the end of a project. But it's important to note that we're only covering off on information that is required to own, operate, maintain, and do that safely and as efficiently as possible, and also demonstrate compliance to the regulator. CFOS can be used across multiple industry sectors, but most in the process plant industry sectors will have a regulator of some sort. When we talk about it being a handover specification, there are multiple handovers throughout the life cycle of a facility, and to own something in the first place, that own part, you have to be able to buy it or procure it. So it covers right from the procurement of equipment all the way through to operations, and then ultimately to either abandonment, disposal, or handing over an asset to another organization. And also what we're seeing is that there is a significant lowering of the life cycle cost associated with poor or incorrect information and missing information. And actually now some of our members are really seeing those benefits, not only in the project phase where they're seeing significant savings in the procurement cycle, but they're right through to the operations phase. And some of our organizations are actually doing far more with the underlying good quality information that they've received for a project, and actually providing insights into their assets and sort of increasing their reliability or availability figures. So significant savings being seen, real savings. Okay, just a little bit about the key elements of CFOS. So CFOS is really divided up into 3 key blocks, if you like. These are our key deliverables. And one is what we call our narrative documents library. So that contains a number of documents, such as the scopes and procedures document, and that defines how to scope out information management to support the delivery of CFOS and the requirements of CFOS. We have our technical specification document. Those who are familiar with CFOS will know that we refer to it as the spec doc. And that is sort of the rules and the principles about information handover. Then we have a number of guidance documents to help with the implementation of CFOS, some lessons learned in there and what is good practice in terms of implementing CFOS within an organization, be that an owner operator, be it an EPC contractor, or be it an equipment supplier. We are just at the moment developing the equipment supplier's guidance document. And then that's all supported by what we call the contracting scenario templates. You don't necessarily need all the information about a particular asset or a particular piece of equipment at the various project phases. So the contracting scenario templates helps you form the scope of work for the particular contract phase that you're in, be it, say, concept select, or going into feed, or going into the execute phase, all the way through to the operate phase. So that's the document library. Then we come to the data model. It's important to note that the CFOS data model is a logical data model. It's an aid to help assemble the CFOS RDL. So it contains all of the entities and the relationships between those entities and the properties, which allows you to implement the RDL. And that's the final part, which is really the reference data library. And that consists of naming of all equipment, all the equipment classes, and all the properties, and equally documents that are required against a particular equipment class. Whether you want the data and or documents, because we have to live in the real world, and we know that not all organizations are actually data centric. In fact, there are very few that are truly data centric. They still rely on documents to a greater extent. Although we would like to see at some point, obviously, everybody moving to that data centric world, but it's a way off yet in reality. Just talk about our membership. Our membership has grown over the years. So we're now sitting at around about 83, we are sitting at 83 organizations, and they come from the various, what we like to call our membership groups. So just quickly going around the clock there, we've got what we call the IOGP owner operator groups, and there's 14 of those. And you can see that there's some of the world's major super major oil and gas companies in that group. We've also got what we call the non-IOGP member owner operators group, and they contain some of, they cover multiple industry sectors, such as the nuclear industry, say there with Sellafield, and we've got a number of chemical companies, and other production companies. We've also got the water industry represented there and some power companies represented there. One area that is underrepresented within CFOS, and we're working hard to try and improve that, is what we call the equipment suppliers and other institutions. We've got 6 members there, but we would like to get some more equipment suppliers and also some more academic institutions involved with CFOS. Moving around to the EPC contractors, you can see that there's over 22 EPC contractors currently involved with CFOS, and again, some of the world's major EPC contractors, not only covering the oil and gas industry, but covering other industries as well. And our biggest group by far is what we call the software vendors, and consultants group, and that has 31 members there. And as you can see, I won't pick out any names, but it also contains some of the world's largest engineering software suppliers, as well as other software suppliers supplying software that is most of it does contain CFOS within it. So 83 organizations, and the people that are actually contributing to the development of CFOS, you know, the reference data library, the data model, and those documents come from over the 400 SMEs that we've got involved. Some more active than others, but still quite a large community of people involved within the actual development of the content. You will hear from Heine and some of the work that we're doing with DEXB around alignment, but CFOS also has a number of MOU partners, industry initiatives that are actually in the similar space. So what we're trying to do through our MOUs is to make sure that we have alignment. We don't necessarily have overlap, and we all talk a common language. We use the same names or the same references, and also the similar properties, and the properties align. And we have been doing some work with DEXB around making sure that our class libraries align. And also, if I was to pick out another one, we would say we've been doing a lot of work with SEIIA, which is the Construction Industry Institute, particularly around advanced work packaging and making sure that their data model is purely an extension of our data models, and the two data models work seamlessly, and the classes and the properties where they're already within CFOS, they refer to the CFOS properties. If they are purely required for advanced work packaging, then obviously they define what they are, but they use the same base rules as we use within CFOS to align or to develop properties and classes. It's important to say, though, that CFOS doesn't invent anything. We always look for a base standard, and within the reference data library, you will always find a source as to where either a class or a property or an attribute has come from. And typically, our first port of call for that is ISO 15926. We're also working very closely with other ISO groups, a couple here, 14224 around reliability, and making sure that we get alignment between CFOS and what's in ISO 14224. We're working very closely with them. Okay, so move on to a little bit of overview of version 2. We follow the semantic numbering convention or naming convention for versions, and our last version was version 1.5.1, which was an interim publication, but we've now published version 2, and it's fair to say that version 2 is our biggest single published version of CFOS since the initial version way back in 2013-14, I think. It contains over 26 feature requests, and it's a significant and extensive update. And it's important to note on the update, we are very conscious that organizations that have implemented CFOS, we don't want to have any regret costs to them. So we are always trying to update. We do deprecate things occasionally, but not very often. But the underlying core data model, even though we've done extensive extensive modifications to the data model. The underlying core data model is still the same. There are extensions to that data model and extensions to the RDL. But one of the key reasons or key reasons that we've gone to version 2 is the fact that we've actually refactored our specification document. This is the first attempt that we've had at actually going for a true requirements document that can be machine interpretable, and we've gone away from narrative, and we've gone to a single requirement, be it a should or a shall or a may requirement still, but a single requirement in a single paragraph with a unique reference, so that when it can actually be downloaded through say a RecIF file into owner operators and EPC equipment, EPC contractors into their requirements management systems. Most organizations these days we see are actually moving to that, and that's why we've been requested to change that. As upcoming in the next release will be some of our other documents as well. We'll be refactoring them into requirements documents. We've also updated our units of measure, and we've also included, and I'll go into a little bit more detail about that, we're also included for greenhouse gas emissions, particularly scope 3, so ways of collecting the information that you require to do those calculations. We are not saying how those calculations should be done. There are a number of standards around that organizations use to calculate what their GHG emissions are, but what we are doing is making sure that against the equipment that you can actually collect the information that is required, the data that is required to enable you to do those calculations. They're not mandatory attributes, but if you do have to calculate the scope 3 emissions in particular, then this allows you to do that to whichever standard you choose for your calculations. We've also aligned with the Energistics units of measure, and I've got another slide on that just to cover off a little bit of that. And there is also significant RDL updates to align with JIP 33. And for those that are not familiar with JIP 33, that is another IOGP joint integrated program, which is around the alignment, it's around the generation of standardized equipment specifications. And CFOS is foundational to that, because it supports what they call the the IRS, which is the information requirements specification. So all of the documents and data that you need against a particular class are related to CFOS, and the CFOS unique IDs are in there. And equally as well, they have a thing called the PDS, which is a procurement data sheet, and the underlying data that's within that procurement data sheet is aligned to CFOS. We're also enriching CFOS to cover 14224, ISO 14224, and the requirements for data within there. It's fair to say that we've updated what we call the data model with what we call the groupings and component extensions to the model, which allows us to accurately model things like the boundary conditions, and it also enables things like the procurement data sheet to be able to group those particular attributes against those particular classes. So that data model update is significant in enabling some of these things that we've got on here. So I won't go through all these in detail, but as you can see that there are a significant number of updates to the RDL, to the document RDL as well, because we have one for data and one for documents. The data model has significant updates. The implementation, as I say, we've refactored the specification document, and there's been a number of bug fixes and other things that have gone in there that we cover that under the project section. Just to give you some idea of the scale of that, so we've had over, or very nearly 52,000 items affected within the RDL. We've added over 16,000 items to the RDL. Now they will be either properties or classes, and we've only terminated 837 items, and we've actually edited another 35,000 items. So as you can see, it's a significant update to the RDL, and also the data model with the inclusions of things like the groupings and the component models, allowing us to do those things with ISO 14224 and JIP 33 and others, as well as including things like being able to group properties for spare parts as well. So as I said, we have actually refactored our specification document under this update, and basically what we've done is we've made it so that it is a machine readable document, and actually whilst we publish the text version of that document with the unique requirements, we are actually going to be publishing a REC-IF file, which will allow that to be passed from machine to machine, and included in some of the requirements management systems that that organizations are using now, as I say, be that owner operator, and also EPC contractors, and in some instances equipment suppliers. Some of the major equipment suppliers are using them as well. So as I say, we've added additional attributes to allow for GHG calculations, particularly around scope 3, and it allows you the attributes to calculate what's called cradle to gate. So all the manufacturing GHG properties are there so that you can actually do those calculations. As I said, there are a number of ways of doing those calculations, but CFOS is not actually telling you how to do the calculations. It just allows the data to be collected to enable those calculations. We have upgraded our units of measure. We've aligned to energistics. The reason we've done that is because we found that we were aligned to the UN in the past. We still have those references back to the UN, but the UN and other units of measure all sometimes require special characters to uniquely identify the units of measure and enable machine-to-machine translation. And that can mean, in some instances, that you have issues with the transfer of units of measure. But by using the energistics, there is a unique reference that means that there's no confusion between between units of measures, and it enables more easily transferable units of measure between machine to machine. But we have also included, as I say, to make it backwards compatible. So those that are still using the UN ECE units, there is a cross-reference within the data library to allow you to use either. But it is a more extensive set of units of measure within CFOS. One very important thing as well is that during the testing of the CFOS RDL in particular, we found that because we've done these extensive modifications to the data model, that actually we'd introduced a layer of complexity that we didn't intend to do. So what we've done is we've taken a decision, and we're actually publishing 2 versions of the RDL. We're producing what we call the core version. So this is a reduced complexity in terms of the way you assemble the RDL. And we've actually made it simpler to assemble the RDL. But it's important to note that there is no loss of fidelity. So if you use the core version on a project or throughout the life cycle of a facility, you will still end up with the same handover events, and you will still end up with the same data and documents being handed over as if you would use the extended version. Now, the extended version is a truly normalized version, so there are no views, there are no joining of entities together and properties. It does include the terminated items. We found in the core version, we decided to remove the terminated items because a lot of people still make the mistake. It's a column in one of the tabs that actually is far on the far right hand side, and I've done it myself a couple of times. If you forget to exclude the terminated items, you actually start to try and collect information that you don't, or data that you don't actually need. It also contains the provenance of the item, so where the source specification. So did it come from ISO 15926 part 4? Has it come from another engineering standard? And it also contains the mappings between all of those standards. So if you've got a property that has more than one source and is known as slightly different things, it will have all of the synonyms and also the sources from where those synonyms have come from. But equally, as we say, it has the same fidelity in terms of the handover event as the core version. Just a little bit about implementation. CFOS has a implementation staircase, as we call it, where we try to measure, or we are measuring, where our membership is along that staircase. It's a five stage staircase. It starts off with pre-adoption, then goes through defining CFOS within your organization, and then embedding CFOS into your organization, and then actually going into use. And that could be using it in a contract between an EPC contractor, between an owner operator and an EPC contractor. It could be defining it in a procurement requisition from an EPC contractor, say, to an equipment supplier. And it's actually actively being used. And you can see from the percentages there, we've got, of our membership, of our 83 organizations, 5% of them are still in the pre-adoption phase. 21% are in sort of like defining it, but the vast majority are either have embedded it in their organization, and almost half of our members are actively using it within contracts. It's either been specified by an owner operator to them to use, or the owner operators have specified it, so it's actually being quite widely used. And there is as well 3% are actually in what we call the assure stage. So that's actually assuring that yourself that you are seeing the benefits that you intended to see by implementing CFOS, and then going and actually applying any lessons learned to your implementation process. And we are finding the members that we've got that are in that group, they're actually now finding that there are other benefits to having CFOS other than the collecting of the information that they need to own and operate the facility. Some of our members are actually using it to measure engineering quality within their operations phase, the quality of the information, the engineering quality. Some have engineering quality dashboards, and also some of them are actually applying AI, machine learning, those sorts of things around the availability of equipment, and actually gaining much more than we ever thought you could, rather than in our initial business case. So we are actually going to look at our business case and redefine our benefits in terms of things that you can do over and above what we expected to be available. And we are finding, as I say, there's quite a lot of innovation in that space at the moment, in the use phase, and in particular in the operate phase, or the sort of like the final assurance phase, where people are gaining huge insights into their facilities, because they can apply the sort of like the machine learning and the AI techniques, because the core foundational information is consistent and is reliable and is correct. Just a little bit of looking forward. We are actually looking, so we've spent a lot of time this year and actually over the last 2 years compiling version 2, but we're now looking at what are we going to be doing next. So we're concentrating on 3 areas of our roadmap themes. One is around data maturity. The other is obviously JIT 33 alignment, and also around implementation and refactoring our other documents. They're the key ones that we are, but there's also a lot of FRs in our backlog that we're also going to be processing as well over the coming months, getting ready for our next release. And we are looking at some tooling as well, that we think that we need to improve the tooling that we've got, or to help us with the delivery of CFOS. Any questions? I have rushed through that quite quickly. Hopefully, not too much over time. Any questions from anybody?
Thank you so much. We have a question in the chat over here from Mikael. You could ask your question if you want.
Hi. Yeah, I would just like to know, we have talked about a lot about the IDO now, and now we talk about CFOS, and it would be nice to hear your view on the relation between the IDO and CFOS, and any activities going on to collaborate.
Yes, so I haven't mentioned IDO, but we are actively involved with the IDO. We have been to a number of meetings, but also within CFOS, we have over the last year created a new working group, because we're divided up into working groups, and that working group is what we call CFOS Semantics, and a number of the people that are actually involved in that working group are very actively involved within the IDO group as well. I've been to a number of meetings. We want to be aligned, and we want to make sure that that CFOS is a suitable reference for the ontologies. Yes, we are actively involved, not only myself, but a number of other people like Onno Papp, John Charles Leclerc, from Technip, from Total Energies. They're very actively involved as well. So we are staying aligned. We don't have an MOU in place, but we have been actively involved in the work that the IDO's group has been doing, particularly around the new ISO standard that they've written.
Okay, thank you.
Mm-hmm.
Thank you, Peter. That was really interesting. Next on stage, we have Heine. Welcome.
Yes, thanks much. I hope you can see my screen now.
Yes, but it doesn't look like presentation view. Now we see presentation view. Thank you.
Okay, good. My name is Heiner Temmen. I work for more than 3 decades for the global chemical company Evonik. Now I'm retired, but I still work in the community. And yes, 5 years ago, I was in Upplands Väsby to present DXP the first time. As you said, Erik, you started with DXP, and we had a very good discussion about DXP 5 years ago at the first summit. Now I will present a little bit more about the work in the last months, about the alignment between DXP, CFOS, and ISO 59026 Part 4. And it's good that Peter Townsend gave us a good presentation for CFOS in the last minutes. And today I will speak a little bit about the alignment scope, a little recap on DXP plant, and view what are the common concepts from CFOS and DXP, and then go a little bit more into detail with the alignment scope, and present some examples, and report a little bit about the status and the next steps we will do or we can do. And that's a slide Peter had in his presentation. And here we see from CFOS and DXP, there is a memorandum of understanding. And the main objective is that we can use CFOS and DXP at the same time. And the strategy is behind this objective is that we need common configuration of the used software. And we saw that we have in CFOS, several software companies were involved in the CFOS initiative. And if we have a look on the view of the life cycle, this is a picture from the ISO 59026 guys, where they have a view on the different information structures we need for the whole plant life cycle. To the left, we have the world of the, let's say, chemical processes with activities and streams. That is covered now by the new part from DEXB, the new module. David Cameron, at the beginning of the sessions, he was online. He is the main author of the DEXB process module. And the typical one, DEXB P&ID, that covers the area of the plant. And I'm one of the authors from DEXB Plant. And we started now 12 years ago with our work. And then the next information structure is the world of the products. And these products were then later from the market. They were bought from an owner-operator or EPC and invented as assets. The digital product passport, that's here in the, let's say, purple world. From pale blue, they have to deliver the device vendors, the products, and the products were invented as assets, and in future with digital product passports. And here we see that's the area from DEXB process, and in the middle the specification world with the functional and the physical things that is covered by DEXB plant in the structure. And if we go to the CFOS data model, one of the main deliverables, as Peter said, is the CFOS data model. And here is a picture of the structure. And to the left, we see the process world in orange. In the middle, with blue and green, with the same colors as before, we see the world of the plant. And to the right, they call it equipment. And here we have the process to the left, in the middle the process plant, and to the right equipment or assets, in the same meaning of the term. Here we see in the middle, it seems to be the smallest part, but the tags in the middle of the CFOS data model, they are tags is the important part. And here we see as well, they have a concept for asset types to reduce, let's say, the amount of assets or equipment they need in the kind of spare parts. And we concentrate in our world with the alignment on a common taxonomy between all DEXB plant classes and all CFOS tag classes. And to recap a little bit about DEXB, that is the typical things from a P&ID. It's not a document. Of course, it's a document, but it's a representation of data. And the data is from the different disciplines, piping, instrumentation, and apparatus and machines. That are the three typical disciplines where the items are represented, how they were constructed together, or how they were worked together in kind of symbols, labels, and topologies. And there is some old stuff like off-page connector annotations and title blocks as information. But DEXB as a standard for P&IDs is not a document standard. It is a data-centric standard, covers these disciplines and covers how to handle symbols, labels, and the important things, the engineering content. That means what is the topology between the different items on a P&ID. And similar to CFOS, we don't, it's a new standard, but it is, we use existing for our specification. For the plant structure, we had code definitions in ISO 10209. For apparatus, machines, and piping, the symbol worlds and which groups and which classes were needed, that is ISO 10628. For instrumentation, we have two levels. For the more functional world, for the blue things, the IEC 62424, and more for the green things, for the mechanical definitions, the IEC 61987. For communication of as ADL, we use ISO 5926 part 4. And the CAE vendors, they said, okay, for the first implementation, they use Proteus, but now in the next versions of DXP, we change to more non-semantic implementations and use DXP or XML and JSON. And what's important for DXP? Here are several standards, but DXP itself as specification, as a transport standard, is applicable for IEC, ISA, DIN, and let's say for other company internal P&ID standards as well. And we had the first release now 8 years ago. And Erik, as you said, in 2019, you had first experience. You started in Sweden early with DXP. And the deliverables are, the most important deliverables are specifications, our specification, now in version 1.4. And in next year, we will have a common specification for DXP process and DXP plan together. The extension of the Proteus scheme. We have several tools and use cases. And the most important thing is that nearly every important CIE vendor has interfaces for export and for import. And we can see here several software companies that were the same as Peter has it on his slides for CFOS. To have a look on the same concepts from which we have in CFOS and in DXP. The main thing is, do we have the same look on the plant breakdown structure? In DXP, we have the terms enterprise site, industrial complex, process plant, plant section, and plant area. We have two more as additional to support systems as well. And if we had a look at the CFOS data model with its breakdown structure, we could find site. We could find industrial complex. The process plant, the plant here. The only thing is, but it is the same, the plant section is the same as process unit. Process unit is a part of the plant and not a part of the process. The name is very familiar, but it's a little bit confusing. But we see it's the same, and for the geographical things, we have area as well, and that means our plant breakdown structure and the concepts for identification, they fit 100% together. Very important. And here are some other points. We support the same industrial segment, the process industry. As I could present in the beginning, we have the same view on the life cycle. We both say, okay, the class definitions from ISO 59226 part 4, that is our primary resource definition library. We use the concepts from ISO 14224. Peter mentioned perhaps the boundary concept or the concept of maintainable items. Both, we have the same kind of thinking and using them. We use both classification instead of naming rules. That is an important concept point because we have many, let's say, old-fashioned standards, and in history, perhaps they had they were good that they were there, but for the digital age, naming standards, that P100 is a pipe because the first letter is a P. That is history. And for digital representation in future, we need classification systems as we have it with ISO 59226. And both concepts, we have early involvement of the software vendors, some of the important common concepts here and more. And let's go a little bit into the details of our alignment scope. In CFOS, in the version 2.0, we have about 853 tags. Without, that's the view on the core, without the terminated classes. And with the work together with Peter, we identified that nearly 600 were relevant for P&IDs. And then the next step was to divide them up to the different groups, apparatus machines, the piping and instrumentation. And here on the other side, we see how many classes do we have in DXP. We have not so many classes. And the main difference is, as we can see, in the world of instrumentation. And we will see how or why we have many more classes on the CFOS world. But we see more in the moment. We have 126 other classes, and our decision is we will start with the 3 typical groups: apparatus machines, piping and instrumentation, and then we cover the biggest part of the tag classes from CFOS in our common taxonomy. And here are some examples. Here we can see it that we have to the left the DXP things, in the middle the CFOS, and the reference to 5926, and that fits very good, as we have seen some slides before with the plant breakdown structure. And here we have the typical things nearly in every presentation with the example pump. Here we see pump is from group 15 from ISO 10628. We have the subclasses for centrifugal pump, reciprocating, rotary, ejector pump, and so on. And here we see some differences. Here we have another pump. This ejector pump is not part of CFOS, but they have an inductor pump and they have a vacuum pump. And here we see some differences, but in the moment we have it in the same concept. And later on we can discuss, okay, shall this 2 pumps be also in DXP and vice versa, perhaps the ejector pump part in CFOS. That could be a discussion. And here we see a little bit more. We have impeller and displacer for the different pumps as components. In the moment they were not a part of the CFOS world. But that are some small differences in the data model, and pump fits very good together. And next example is from the world of piping. And here we see, okay, many of the valve types are the same, and CFOS has a little bit more detailed other types of valves as well. Common taxonomy also with reference, all reference and primary reference is ISO 5926. And here is an example from transmitter, and we see, okay, DXP stops on the level transmitter, and CFOS has a lot of different transmitter types for the different measurement things, from, let's say, from flow to level to temperature to pressure and so on. And here we see why in the world of instrumentation, CFOS has a lot more types of classes. But on the level of a P&ID, it is sufficient to say, okay, measuring system, there is a component transmitter, and that's it. And we have also the information which type of measurement is it? Is it level, pressure, temperature, density, or what else? And therefore we see the different approaches, but they fit very good together. And the status of our work is that we have a first draft of the alignment table. That's done now. Since 1 week, some DXP subject matter experts review this draft, and when this draft is reviewed by these colleagues, the CFOS guys with the ADL team, they will review this concept as well, and then we can do hopefully beginning next year in the first months with the publication. of our common taxonomy and do it on the two websites from DEXB and from CFOS, and do a presentation at the DEXB update call and the monthly call from CFOS, and to have an electronic insert for the community. We prepare a namespace DEXB, and this namespace includes the DEXB plant and process classes, also with the new alignment things in kind of SCOS mapping to 5926 and in CFOS. And in the MRail activity, we will set up this namespace for DEXB. And possible next steps could be that we enrich, and that's important today for the Swedish community. In the moment, the specific classes for pulp and paper were not in CFOS and were not in DEXB and were not in ISO 5926 Part 4. And I hope we can implement next year's the most important additional classes you need for pulp and paper plants. And we could enrich DEXB plant with CFOS classes and vice versa, CFOS with some DEXB classes. And what we have seen more today is the IDO concept represented by Melinda, and DEXB classes could be part of IDO, and the same could be with CFOS. And in the moment, in the FPVN project, DEXB, to bring DEXB classes into the IDO concept is a part of that project. And the alignment of CFOS and DEXB process in the beginning, we could do it as one of the next steps. And the alignment with the activities from USPI, the 3D activities, FL3, DMS, we started these activities that the classes from CFOS and from DEXB were aligned with the content table from the 3D specification from USPI. That was a small and quick overview over our activities, how we try to align the specifications from CFOS, DEXB, always have in mind with references to ISO 5926 Part 4. Other questions?
Yeah, thank you so much, Heiner. I think I have one question for you to begin with, and that is, when do you think that the alignment with CFOS will be completed? And what resources do you think is needed to make it complete?
I can answer that on the different level. The most important step in the first month of next year, then we have it and we will publish it and have an electronic insert for that, then it can be used. And then we have to work at the, let's say, extensions. First of all, hopefully with some classes from pulp and paper. I hope, Erik, next year we will get them and can implement them. That is not a big point of work for the MRail community, for CFOS and for DEXB as well. And then we can go to the next steps, enrich DEXB with CFOS and vice versa. And I think everything we need, we see here, we should try to reach it in the next 3 years.
Thank you.
Thank you.
Do you have any question from your behalf?
No, but I see we have a question from Johan in the audience.
Do you want me to read it?
Yes, please.
Okay, thanks. How is the situation today with standards and data interchange around electrical circuit diagrams? They are commonly the next step after the PNIDs. That's my question.
Okay, we work together with our Namur guys, and perhaps you know Andreas Schüler supports this area from the Namur, and there is a new Namur recommendation. I hope I have the right number, 193 or 191, and that handles your topic, and how, if they will build up a DEXB similar, let's say, module for that as well. I do not know. Perhaps I can ask Andreas in 2 weeks. We have a common meeting about the life cycle, about the DISC project, and there this topic, I think, is also present.
Thank you very much.
Good.
Thank you.
Thank you very much, Heine. And that takes us to the last but not least point of the agenda. Erik, will you join me here on stage?
Yeah.
And I give the word to Terese, I think.
Yeah, I hope I have my microphone on. Yeah, I have.
Yes,
Great. Yeah, I think this has been a really interesting afternoon, and I think my main feeling after listening to all these presentations is that it's really a lot of great work going on in this sector. Wow, it's really an interesting time when a lot of work is happening in different parts of this sector, and that a lot of people want to walk the same direction. What do you feel in the studio?
Yeah, I'm part of it, so so maybe not so. It's part of my daily work, so I think it's. But that's, as I said several times before, that SEIIA works. The work we do in SEIIA, it's 50% national and 50% international. We have Nils Sandsmark on the call. We have Heine, we have Arto. We are working together in a very good way and try to contribute in several ways. And so for me it's natural, but I think it's good. It's also good to show it in this type of presentation that we have today.
Yes, and I can just tell you the same thing. As been a part of SEIIA for a couple of years, I think every year I see that we move a step forward. So I think I used to say that we always live in interesting times, and I keep on saying that.
So maybe I should show this picture then, and you can tell me the best reasons to be a member in SEIIA. What is that? Erik, shortly from you.
It's to be a part of this development that we do together on an international base, I would say. And we are the Swedish hub or connections to that work that we do together on an international way. But and also to be a part of the Swedish development of interoperability in digital information exchange. I think we need to do it together, and to do it in a community like SEIIA, I think it's the best way. And we need also, in the end, we need resources, because it takes time, and it also costs to be involved in this. And as we discussed earlier today about the digital project passport, it costs a lot of time to be a part of this work. And so it's two ways. Both the organization needs the members, and the members needs us, the organization. So it's we can't do it without you, and together we do it.
Great.
Good. Wise words from you.
Yeah. Okay. And did you want to say something more, Mats, or do you feel that Erik just had the words to describe why?
I think I just think that was very wise said, and just make that stronger is to be a part of SEIIA is to be a part of the development, and the question is so big that you cannot do it yourself. that needs collaboration, and that needs international collaboration. So by joining SEIIA, you be a part of the development for the whole world.
Great. And then we actually just have one more thing to do, and that is to get feedback from you who've been listening to this afternoon's presentations, and we're looking to all these interesting descriptions about the work that is happening in our sector. So if you just follow this QR code, we could gladly get some answers from you, what you think about this afternoon and the program that we've had. And I think from my point of view, that's actually the last part that we're going to do today, except of saying a big thank you to all the interesting presentations and to all the audience who have been listening today. So from my point of view, that is like, thank you for today. It's been wonderful.
Yes, we from the studio say the same, that thank you for listening for us to this afternoon.
Yeah. Hope to hear from you soon.
Yes.
Thank you.
Bye-bye.
Goodbye.
Bye.
Thank you and bye.